Good morning.
Morning, how are you?
Uh, I'm good. My brain was a little fried after yesterday, to be honest.
Yeah, I'm struggling right now. I can't get it to do what I want it to do.
Yeah, I built the code, but I haven't put the bumper on yet. So that's what I'm trying to, that's what I'll hopefully be able to do today during asynchronous, hopefully.
Well,
I
I'm
didn't do anything either. I was burnt after yesterday. I just quit.
I'm I'm hoping that we didn't have to do anything with that arm again because I sure didn't take a video of the sensor stopping it, and I already took it off and put a bumper on.
I think that I mean, we may have to double check, but I think what it sounded like was that the limit switch arm raise thing was like optional if you wanted to do it, but the main project was the bump switch. But I could have interpreted that wrong. It's really sometimes hard to determine expectations.
Yeah.
Could we put it on the other end, like the back of it, and then reverse the motors, maybe?
Yeah.
Or that's the front? I thought
Well, I
about
mean,
doing that.
I could put it back on. That wouldn't be a problem. I just took it off because of the location of the bumper. It would
Right.
have been the motor arm itself would have been in the way, and it would have hit the arm before
Yeah.
it hit the bumper.
I got you.
So I mean, I could put it on.
Well,
It would be
well, the
annoying, but
reason why I'm asking is because my front does not have a bar on the front, but the back of it does. So, um, the, I'll show you what I mean. Well, let me unblur my screen, maybe.
well, you
Should
can
not have
always
put on
just
loop
make your back your front.
Yeah, that's what I'm saying.
Yeah.
Is that where you just reverse the motors? See how it doesn't have a bar in the front, but it does in the back.
I mean, you could reverse the motors, or you could just have all your commands be go backwards instead of go forwards.
Yep, like
Okay.
your forward is your backwards.
Yeah. You
Okay.
just have to remember that. And you can show me that again. Show me your back again. So what you could do, and it shouldn't be too hard, is you take you have one of the red bumpers, the red bump switches. What's the cap look like? Does it have a screw in it?
No, hold on.
Uh,
Oh, that's the old one. Okay.
yeah,
Um,
because
There's
if
a
you have a
newer
new
one.
I
one,
actually use it as a bumper.
yeah, that's what I did.
Yeah,
Like
that's
I
what I
took
did too.
the cap off and then put this little, so like I actually made a bumper.
Gotcha. Yeah, the
So there's
old
a
ones you
newer
can't do
one.
that with. Yeah, the newer ones you can
There-
get like a 2-pack for like $15 or something
Yeah,
like that.
and this is the cap I took off.
What does the
And
newer
they
one
don't.
look like? Miranda, do you have
Huh?
one?
What?
What does the new one look like?
Hold on one sec, I'll get the pack.
Okay.
Hey guys.
Probably have a new one.
Hey Eric, I think you mentioned this. The sonar, or not sonar, but
Rangefinder, yeah.
the rangefinder, they don't sell that anymore, right?
No, they
It
do.
looks like this.
Oh,
They-
well then
Oh,
they have
okay.
They still have the it's the older vision sensor that they don't sell anymore.
Oh, well, I can't find the range. Hold on. I couldn't find the rangefinder on the Vex site.
Let me look to make sure, but I'm pretty sure
I just typed in rangefinder. It doesn't pull it up at all. But then whenever you go to if you just go to Vex V5 and you go to their electronics, it's not there.
Hold on. Let me see if I can pull it up.
Now it might be one of those situations where they still make it for these kits that they sell to like PLTW and different and an LSU kit, maybe if LSU has a specific kit that they have.
I could have swore I saw it the other day. Let me.
Oh, you might have. It's not pulling up for me.
Maybe not.
But they have the old bumper switches. It's like, why would you have that? But you don't.
Yeah.
All right.
They actually have all 3 versions of the bumper switch.
Yeah. Which if you're going to buy some, I would recommend
The V2.
buying the well, obviously buying the V2, but also buying the 6 Newton ones.
Oh, okay.
They're just easier to press. Huh. Actually, I'm not seeing it now. I could have swore. I saw it.
Yeah, they might need to change out that unit instead of using the rangefinder, use the distance sensor or something like that.
Yeah.
Because that's what I'm going to have to do.
Yeah. Yeah, and if you have an EXP kit, well, yeah, I don't see it listed here. I wonder if it's still part of the kits. Let me let's see here. Let me see if it's still included in the kits. But yeah, I don't see it listed. But I could have swore like as of like last month I saw it on there. But
So you do get one ultrasonic rangefinder according to the super kit.
yeah, so the classroom super kit.
It says the classroom super kit. You do get one rangefinder. Now, I don't understand how you can get one in that packet, but it doesn't show up at all on there.
store.
Maybe they're phasing them out completely.
Yeah. But they have their uses, even though the laser rangefinder. So it's kind of odd. The classroom, I think the classroom kit, does it say that it still comes with the? I'm looking at the classroom super kit too. Six more. It also still has the old vision sensor too. So, yeah, it says ultrasonic rangefinder on there.
Yeah, I'm a little concerned about that though. I don't know. I don't know how much I trust that. Although I guess if they put it in there, they have to.
Yeah, honor it. Yeah. What I wonder if the competition super kit. If you're going to do a team, I would suggest spend the little extra to go with the competition super kit, just simply because all the metal is aluminum and not the competition super kit doesn't come with as many sensors though. It comes with 4 bumpers, and it does come with the old vision sensor still, which they've discontinued. Unless they're saying vision sensor and they mean AI vision sensor, but so in that case, I'm actually in my classroom today. It's a mess here. I've just basically walked in, but my desktop computer, all the wires are not hooked up right now because they waxed the floors. So, but that means that I can grab some other parts in here now. Oh, by the way, this is kind of the layout of my room. As you can see behind me, we got kind of a pegboard where we keep all the metal. I'll just kind of stand up here, and over here is like a bin, like some bins that we got to kind of keep all the other miscellaneous parts. So you can kind of see all the wheels and gears and all the other kind of stuff.
That would make me so happy.
Yep. So I use this inside here. It's like a lot of plugs. So we charge our batteries in there. Here's our tower of trophies. And we just bolted all the trophies together and make a big tower of them.
And y'all bring that out during your competitions to make everybody like very intimidated.
That's pretty cool.
Yep. And then we got there's our field. As you can see, we gotta kind of we gotta get that sorted out. And then we have some more shelving over there. And so yeah, so this is what we use in our robotics classroom.
So you have it raised. What do you do whenever, like, if something gets stuck in the middle, somebody just have to climb in there and go get it?
Yep. Yes. But it's sturdy enough that you can do that. So, but let me grab.
Y'all's volunteer t-shirts look better than first do. Those are awesome. I like that.
These came from Worlds, yeah, this year. Yeah, they're nice.
Cool.
So I have 7th graders, and when they transferred all this stuff to my room, like I had a hard time keeping them out of the parts. So I'm trying to convince the ag shop to build me some because all I have are shelves, trying to build me some doors or something to keep them out of it. It's frustrating.
Yeah, we kind of lucked out with these bins because, like, one of our local, there was a warehouse and they were upgrading their shelving, and so, and we just happened to have a parent that worked over there, and so they kind of brought that shelving over.
I love the pegboard.
Yeah, the pegboard is super handy.
All of mine is just thrown in bins, and they're all different sizes, and you just have to figure out which size you need. Like digging through dirt cheap.
Let me see here. That's an optical sensor, and that's a distance sensor. So here's of course the ultrasonic rangefinder, but I guess they're not selling that anymore. So here is this is the optical sensor. This is the one that can detect colored objects, but it's not. And this is the distance sensor. So it's the laser rangefinder, and so it sends out a laser port. And as you can see, the only really different, well, you can kind of tell some slight differences in the two, but the optical sensor has that little eye icon on it, while the distance sensor has that little distance icon. But otherwise, they're very, very similar. They have the same footprint and everything, so they kind of mount the same way. So, let me see what other. This is a newer rotation sensor. So basically, you run your axle through this hole right here, and it will keep up the rotations.
It took the place of the potentiometer, didn't it?
Yeah. Here's an older potentiometer. They still sell a newer potentiometer too. This is a newer potentiometer.
Yeah, that's the one I have.
Yep. They each actually have their use cases. The newer these potentiometers versus the rotation sensor. The rotation sensor is more if you're keeping up with like a lot of rotations. The potentiometer is kind of well, this is a full 360-degree one, but even so, it's more like kind of keeping up with like really precise but like single turns. So what else do I got? I got all kinds of stuff here. Here's the old rotation sensor with the two our plugs. But it works the same way. You run an axle through it and it'll keep up the spins. This is a really useful sensor here. We got a sticker on it, but this is the inertial sensor. This is the one that actually keeps up with it's robots heading and things like that. So that is a really useful sensor. Here is an older vision sensor. And then we should have at least, yeah, and here is the newer vision sensor. So there's a kind of a big change there. And it's kind of got, like, the newer one has like AI written on the side. And and when you plug it in, it's actually a USB-C plug, like when you plug it in to calibrate it. So that is some of the stuff I have here. So today's word for today is going to be, what's a good word? What are we talking about? How about vision? Vision will be our word for today, because we are going to look at Unit 11. By the way, did anyone have a chance to get their Roomba code to work?
It was real.
It was real?
Well, no, it's still real. It's still not working.
Oh,
I have a code, but I'm mounting the bumper right now, so I'm gonna see if the code works in a little bit.
okay. And you can even test that off the floor without mounting anything, because you could just hold the robot up, and then it should run forward, and then when you trigger the button, it should back up a bit and then turn a bit. And so you could just see the wheels move at the very least, if you wanted to. So you said you were having some difficulties, Josh, or it wasn't working for you?
I'm just, I don't know, for whatever reason yesterday I was very tired, and it was just not, my brain is still not quite figuring out what I want it to do. And it's ugly, and it's not working well.
Want to share your ugly code? We can look at it together if you want. I'm gonna.
Sure.
I stopped by Sonic this morning. I'm gonna nosh on this breakfast burrito while we talk about things, if that's all right.
Perfectly fine. I was
Fine
just
with
eating
me.
a while ago, but I just did it out of video view.
Oh yeah, I eat every day. I forget where I am now. Okay, so I was trying to do the rand number.
Okay. And once again, you don't need the SRAM line, but
Right.
Okay. So I see you have a go forward function.
Yeah, this is.
Now, I already have one suggestion for you.
Oh well, yeah. Here's the top part. So I brought in the code from the basketball drill that we did with the PID control for the forward part, and then for the go back part. And my thought process was I could take the go forward command and put it set to true, and it'll go on forever. Which I already tested that out. That worked fine. The problem I'm having is figuring out the logic that I want for whenever it gets pressed. So in my head, I want it to get pressed and immediately recognize that it's pressed, and I want it to go back, and I want it to go back 1 foot. And then I want it to, and then this is my movement command is going to be my command for it to turn. And so this is where I would input the random distance, but it's not, I don't know, it's just not locking in for me for whatever reason in my head how I want that to work out. So I got down here, and I know that an if statement's a one and done, but every time I tried to do a while statement for while the bumper was not pressed, it kept on giving me this weird. So here, I'll show you. It's probably gonna throw back. It's probably gonna throw out a lot of errors because I didn't finish some code just a minute ago. So it's probably gonna say some crazy stuff. But I tried to do this last night, and kept not working, and I kept trying, and it kept not working, and I just finally gave up. So I did while, and then what did I do? And I said while bumper A, and I think I said not bumper A. While bumper A, not dot. So I did press. I tried pressing. I tried them all. And then I wanted it to say, well, this is true. And then I wanted to do that.
Okay, so you don't need to put anything. You want to say bumper A pressing, but you don't put anything in the parentheses.
See, and that's the thing. Like I tried all these different things, and every time I did, it came back with, let's see if it does it this time.
Now you need another close parentheses because you got to close on line 144. Well, you have two of them, right? Or what? I'm
Yeah,
sorry.
I did, yeah.
Yeah, never mind. Are you sure you got it called bumper A
Bumper A.
in your setup?
I thought I did. Hold on.
It's the little thing that looks like a port.
Yeah. Well, the picture of everything was.
Bumper A with a capital B.
No, I
So-
misspelled.
Yeah.
See, okay, now this is frustrating because I swear, I did this like I did every version of this last night, and this part the whole time, even this morning, this didn't work. Every single time I did it, this didn't work, and I'm about 98.97% sure that I did it this way, and now it's not coming back in error. So that makes me feel better. At least I wasn't crazy in what I was thinking. Okay. So now what does that mean for me? All right, so equals rand. All right, so equals rand.
So another thing I would want to say. So you have go forward true. Well, true is a Boolean value, but it also evaluates to one. So when you say go forward true, it's basically like saying go forward one, and so that's kind of why you probably didn't get an error.
Well, what I was going for with the go forward true was for it to just go forward because I don't have like this is the unlimited part, right? We want it to continue going forward no matter what.
Well,
So I did a reverse, Josh. I put the while true first and then went to the bumper command. So like while true and then bumper not being pressed, and it worked.
well, you actually that so in your go forward function, that what you're feeding in is feet, and it's supposed to be an integer that you're feeding into it.
Oh, I got you.
And you're just feeding in a boolean instead.
So if I
No.
wanted to show infinite feet, what did you say that we
Well,
would
it's
do?
going to loop, but it's going to loop as long as the button's not being pressed. So
Yeah, it's
if
true.
you put in a 1, the only problem with that is it's going to be checking in 1 foot increments.
Right.
So, which actually can be a problem if it never reaches 1 foot. Like, say, for instance, if it hits a wall and it can't move, and it never actually gets the encoder count for the next foot, then the easiest thing to do is you could have just done like a left motor spin, right motor spin, inside that loop.
So
And you wouldn't even need the go forward function.
so I could just do this bottom part. That way I keep the PID control.
Okay.
Motor spin forward, speed minus KP times air volt.
Okay. If you're trying to keep the excuse me. I'm chewing. Yes, that's right. If you want to keep the auto correcting, you could just keep that part. But you also need to keep the line where you're calculating the error. So you want to keep basically 121 through 123. And I would also go ahead and do a set position before the loop. Will that matter?
I wouldn't think.
Well, it would because it's using your motor positions to keep up with the error. And it would be, by the way, left motor dot sets position.
Yeah.
And
I think I grabbed the code from the backup, not the forward part. I did.
okay.
Okay, so I had to switch up a couple things. All right, so that part's that. So this is rand percent.
So it's a function that ran. Yep. So you do need to do the open and close. And fortunately, since it's a screenshot, you can't just copy and
Yeah, I was just trying to look and double check what I had on there, or what it had on there. Okay, so rand percent.
ran open and close parentheses. And then I'll probably just space percent. And how about we do like 181 minus 90?
Well, doesn't it give us
Or does it tell us like
doesn't it tell us a specific number?
It might.
Like 1400 or something like that. So it's between 400 and 1800. All right. So
I wonder why they picked that, because that's just an odd number. Because that's going to spin it around like a lot.
so 1400, what was it? 1400, 800? 1800. So it wants it to be a 1401 difference.
Yeah, 1401.
And then it wants it to be at 400 as the start.
Yeah.
value.
It'll be a plus 400. And then don't forget the semicolon. Yep.
And then this would print percent. This would print random number is. Okay. Percent D
Mm-hmm.
and rand.
Cool.
Okay.
I don't know what's the error with random.
Well, I'm wondering if it's now going to be fixed since, yeah, because I hadn't finished all of it earlier. That's what I was thinking was going to happen.
Okay.
Okay. All right. So that part. Okay. All right. So now we need to come down here. We need to do a while loop.
Well, okay. So first off, okay, you have that while loop, so it's going to be going forward while it's not being pressed. But then right afterwards, instead of doing an if statement or anything like that, it's been pressed. So at this point, you don't really need all that. You can just go into what you're going to do, like backing up and turning now.
So this is while it's not pressed.
Yeah,
And
that's why.
so
And so after it's pressed, it's going to leave that loop, and then that's where you
so
want to.
so this is not necessary.
Yeah, none of that is necessary.
Okay. So that's not necessary, which means now I need it to go back, and I want it to go back 1 foot. And I also and then I want it to do movement. And I want it to do movement for, and this is where I have to do random.
Okay, so you're going to run into a problem there, and the problem is,
Because they might turn different directions here.
well, it's not just that. The problem is that rand number is just existing inside the function. So if you're trying to call it on outside the function, it doesn't exist out there. Honestly, what's
Didn't I
your
put it in the
better
function up here?
What's that?
I said that. So I'm not. Aren't I calling on the function now? Wouldn't that bring it into play?
No, because um, because when you say random number there, that means that there's got to be a random number that exists globally, but it doesn't. Honestly, I would do some changes to your function, your movement function, line 129. First off, I don't think you need any parameters for it. How about just remove all the parameters? Because you're not using speed L and speed R.
I thought that we were using that to create a point turn.
Well, you're doing a 50 and negative 50, but you're not actually using the parameter speed. You're not. There's nowhere in that function where you're saying speed L or speed R.
Oh, I see what you're saying.
So since you're not using them, just get rid of it. So you can just and in the same way, you don't necessarily need a turn distance because your random number is your turn distance, right? So instead of saying turn distance there, just say rand number or random, and that will be your turn distance.
I was trying to go through the PowerPoints and steal the various things and use them, and it wasn't.
Mm-hmm.
Obviously, it wasn't coming out quite how I wanted it to. So that we said we don't need.
No, well, leave that. Leave that. I would put that back. Can you just control V it back? Or control Z it back?
There it goes. All right. Thank you.
Because you still want to set those speeds to turn, but
Right.
it's just
And then that's how far that's okay. Yeah, that makes more sense.
and then when you're calling on the function, you're not going to put anything inside of movement there. So you're not going to say movement random. It's just going to be blank. Like on line 154. And then both of those need a yep.
So I guess this would be my next question. So now that I'm out of the loop, I've done these two, and now I just go back to being out of the loop again, right? Or back into the loop. I'm sorry.
Well, you need another loop.
That's okay. So there should be a while loop in front of this while loop.
I would put it on line 142. And
While running.
while true, because you just want it to repeat forever. Yep.
Gotcha.
And I would open up a But then I would close it off at the bottom of movement. Yeah.
I keep on forgetting. I went back and I changed it from one. So this originally was all lowercase. And then whenever I got it over to this one, I changed it to try to be more camel case.
Mhm.
And I keep forgetting which one I'm on. All right. Well, it builds well.
Yeah.
I guess there's only one thing to do now.
Yep.
All right. Fingers crossed.
And by the way, notice that you can create functions, and you don't necessarily have to use them after you created them. Like for instance, you have that go forward function right now, but you never called on it anywhere. But you can make all the functions you want and then just call them as you need them.
I tested mine too and it worked.
Great.
I just have to video it now.
Would you like to share your code, Miranda, and kind of explain what you did?
Okay, so I did the auto straightening, not the PID loop, just because it was more practice typing code for me. So
Okay.
I first declared my variables because I knew I was going to do the auto straightening. So I was using the voltages for the fast and slow speed when the motors would either get ahead or behind each other.
Okay.
So that's why those are integers, because they're going to be whole numbers. So then I made my first function, which was just the moving forward function. And so basically I just kind of like took what we did with the auto straightening and just kind of used that as like my moving forward. I did rewrite it just to kind of get it more in my mind. So the first statement was, if the left motor was spinning greater than the right motor, then we were going to slow the left motor down and speed the right motor up. So that's that first condition. Then else if the other scenario we've got is the left motor is going slower than the right motor. So we're going to speed up the left motor this time and slow down the right motor. And then if all else, like if those two things aren't happening, then that means they're probably keeping up with each other at about the same speed. So we're just going to send them at the fast speed, both at the fast speed voltage. So that's just going to happen.
Yep.
So then I wrote my move back. So this would be when this is the function for when the bumper gets pressed when it runs into the wall. So I want it to, of course, stop because I don't want it to keep running into the wall. So the first thing I did was I stopped and I braked it for that. And then I put a wait time in there just to kind of give the wheels a second to like stop actually moving for that, because it hit the wall pretty hard. I was not expecting that. So my poor paint. But in any case, so I put the wait time in there, and then I did a spin for one turn because it was 1 foot. So I just did the one turn to back it up 1 foot. And then I knew I wanted it to turn with the random number generator. So, and this one got me. I had to have help to figure out the random number generator because I misinterpreted the assignment as like pick a range from 400 to 1800 or whatever. I didn't realize that that was the range they were setting for me. When I figured that out, it made much more sense. So I did the range for those and then plus the min value. And then I turned the motors opposite directions to get the actual turn to work. So basically I turned the left motor forward at that random number of degrees that I just called on there in that variable there. So I made that variable inside the function and then made sure that that one was false so that it would do those two things simultaneously so that I would get my point turn. And then after it turned, I told it to wait for another 5 seconds. And then that's the end of that function. So how I set it up, and I really like functions because like when I'm trying to think through like the actual loops themselves, not seeing a lot of junk in the code was super, super helpful for me personally. So I just put while, like I did a while loop nested inside a while. So while true, so while the bumper's not being pressed, so little exclamation point is not. So while the bumper is not being pressed, we're going to plug in that movement function. And then once it gets pressed, we're going to pop out of that loop and go to that move back function. And then that loops back into the while true and it goes back to running forward.
Yeah.
And it worked.
That looks great. By the way, how much is it turning with that 14 with that range?
It looked just like a Roomba. Like it turned enough to run in a different direction.
Okay. But did it do like multiple like loops or like did it well what I mean is like was it spinning around multiple times or did it just
not that I know. Like you mean during the turn itself, like was it making like spins?
Yes.
Not that I noticed yet, but I only let it bump the wall like 3 times because I just painted my kitchen. So I didn't want it tearing up my walls.
Yeah, that makes sense. Especially if you put that metal bumper on there.
Yeah, I did.
Yep. Yep. Oh, great. And that's and I really like what you did, especially in the main part of the code, how you got it all simplified. That looks really good. Yeah, that's a great job.
Okay, I have a question.
Yeah.
How do I hook this to my robot? I know there's got to
Okay.
have a connector somewhere.
Yeah, it's on the side opposite of where the battery plug is on your brain. You should see a bunch of slots on the side, and they're like labeled, I think, A through H.
Okay. All right.
And you push it into one of those.
Okay.
And then it needs to you need to push it in all the way in so it's flush. You don't want any of the tabs sticking out.
It doesn't fit. Is there a piece that's supposed to go on the end of it?
What do you mean on the end of it?
Like these 3 prongs do not fit. Okay.
Inside the slot?
This is what I'm dealing with.
Yeah.
Is that right? And then it goes into here?
They can only fit one way, so be careful. You got to turn the right way.
Yeah. I think
Oh, got it. Okay, there we go. Never mind. I got it.
Mine's epic fail.
oh, what did your code do?
Well,
Or
so
what did the code do?
whenever we kicked out of the loop, it did go back. So it did all that right. But then I'm assuming since it's not being pressed, whenever I called on movement, it never registered to go to movement because it's already gone back. And then it didn't do anything whenever it hit movement, and then it just went straight back forward. But now, whenever it bumped again, it just kept driving.
So you mean so it didn't it was just going forward and not triggering the going back?
Well, so it went for so first time it went forward, it bumped, it backed up, so it did everything right up to that point. but then it never turned.
Okay.
And then it just drove straight back forward. But this time, whenever it bumped, it just kept trying to drive.
Okay. So the second time through, it didn't. But the first time it didn't turn.
So my thoughts are that because I'm calling on that function when it's pressed, it did the function for go back, but then it's no longer being pressed. And so
Mm,
now movement doesn't happen.
well, no, because it's going to run those in order. So after it's done with go back, it should move into movement. It and let's look at movement again. So you're making the random number, and oh, did it? By the way, did it ever say on the brain the random number is blank or random number is anything? Because that will let you know if movement was being triggered or not.
Yeah. Let me hold on. I'll tell you. So yeah, it triggered it. It just didn't do it.
So it did show. What random number did it show? By the way, what
12 something.
12.7? Okay.
Is it? Well, no, because I have the velocity set as. Wait, is okay. Are these conflicting commands? Or no, I guess they're not. Because what I was going to say, what if I put negative random number here?
I know it's missing. And actually, okay. First off, you actually probably don't need the set velocities. Take out those lines.
Yeah, and just put one as a negative.
Well,
Since I'm
yeah.
doing it, I mean,
Well, you when you use spin forward, you're supposed to say the direction first. So you should have said like forward random degrees, and you don't have to have the direction. So yeah, but on the second one, you could just do negative random degrees. Yep. Yep. And that should make one go forward and one go backwards.
okay. Let's try. I'm sorry, everybody, if this is.
You're hogging all the screen time.
Yeah, I'm out of it. Well, I guess one positive is people who were having a similar issue to me are maybe getting their question answered.
It's helping me, so go ahead.
Well, I mean, my thoughts were I was trying to steal it from, well, not steal it, but I was trying to make changes to what we were finding in the stuff that we had been learning yesterday, and it just wasn't working out right. I couldn't figure out why.
Oh yeah, and the kids are going to do that too. They're going to just kind of try to steal whatever code they can find. If they don't go to like Chat GTP to write their code for them.
All right, it works now.
Okay.
Yay!
Yeah, success. Thank you. Now, there is one negative, though.
Okay.
If so, I put a long bumper plate on the front of it, but if it just misses that bumper plate and it bumps it anywhere else, you're gonna run into all kinds of wonky issues. But
yeah.
But other than that, it works. It does what it's supposed to do.
Mm-hmm. And actually, that's one thing where if you were to replace the bumper with an ultrasonic sensor and then have your condition just be if it's less than say 5 inches away backup, um, that's actually a little more reliable than relying on hitting the bumper just right.
Yeah.
Because another thing that can happen, like in Miranda's case, for instance, like she has that long strip as her bumper, but it could like hit the side of the strip, but actually not push the button in.
Yeah, that's what happened just a second ago. It went right at the edge of it
Uh-huh.
and it grazed it, and you could see it moved it, but
Yeah,
it didn't, like you said, bump it. It just kept going.
yeah, because it grazed and pushed the plate in or the strip in, but it didn't actually push enough to trigger the button, push the bumper in.
So
Um,
for mine, it definitely had enough force to do that, but as it ran around the house, the little strip definitely got more and more wonky and beat up. So it
yeah,
was probably, if I was gonna actually use it for like a competition, it would have to be a much sturdier bumper.
yeah, and you're also only mounting it to one screw, so it's not like it has support. Now, another way around that is you could use two bumpers, and you could just put one on either side of the robot and have the strip in between. And then you could just set up the code that, like, if as long as A is not being pressed and B is not being pressed, then go forward. Um, so it's just checking both the buttons.
I
Another
think
thing.
Miranda wanted her house to get clean really fast. She had a thing at max speed.
Yeah.
Yep.
Actually, no, it was at half speed, but it was still trucking.
Are your gear ratios 1-to-1?
Yes.
Okay, mine are still on the torque version.
Also, these buttons kind of break pretty easily. I mean, you can pull off the cats off of them. So, but I think they're meant to kind of detach that easily. So, if they get really hit really hard, they're gonna pop off. Um, but yeah, there is a pretty strong spring in that button. So, so once again, if you're having to order some bumpers, I would order the 6 Newton ones. So they have black caps on them. If you're on the store page, they're just easier to trigger because the springs aren't as strong. Um, how about like Sandra and Raven and Ashley? Did you guys have any luck with yours?
Mine works, but what I wanted it to be the front of my robot. I have to plug in my code as reverse instead of forward, or it goes backward.
Okay. There's actually a really easy fix to that. When you're setting up your devices, you know how you just reverse the other motor instead.
Okay.
So instead of reversing the left motor, reverse the right motor and leave the left knowing normal. And yeah, and anytime the robot's going backwards, that's the way to fix that. Just reverse the other motor instead.
I'm still writing on, I just got my bumper on, but I'm trying to finish up my code. So
Okay.
that's what I'm working on right now.
How about you, Raven?
I'm still writing my code.
Okay. Are you running into any problems with it or?
So whenever we put in the RAN number,
Uh-huh.
are we putting a number in the parentheses, or are we just putting the percent of whatever? Like, you know how in the PowerPoints it was like percent 10 plus 1?
Yeah. So and let's pull up that PowerPoint. I'll share my screen. So yes, so hey. How's it going, Hunter? Yeah, the floors are nice and shiny now. They're right.
Yeah, it's a lot better than what it was. Especially right here.
Yep. But yeah, the game elements in the field are still in my car. Of course, we got to clear out the field.
Yeah.
First.
Did you hear that LEDs are illegal now?
Are they?
Pretty
Illegal?
much, basically, someone submitted a stupid Q&A. It was terribly worded. Every one of their scenarios set them up for failure. And it was basically like, okay, so we can have LEDs on the robot because they're non-functional decorations, but we can't have another microcontroller to control them, right? Because we can't have any other microcontroller. So we can hook them up to the brain, but most of them don't have a 3-wire port. Can we solder them? The answer was no, obviously. You can't solder anything.
Well,
So unless there's probably, you could like strip the cable and thread it together. And I think you can take this legal to like cover up cables, isn't it? Because it's not necessarily taping it together.
so what we have done in the past, we had some simple LED strips once, and we like say had like an old one that wasn't working, and we just snipped it off, and yeah. But they're saying that's
You can't solder it though. We can't solder it to it.
okay. Well, you could still.
There's other ways. You can
Yeah.
like strip the wires and thread them together.
Yeah.
And then you just wrap tape around it, because that's neat to wrap tape around something, or a wire at least.
Yeah. But Raven, I'm sorry. Let me get back to your question. So you're talking about the random number thing, like right here.
Yes.
Okay. And so,
I just got
really, to set up that random number, you would just use line 34. So basically, you're just creating an integer called random, and then to generate that random number, you use rand, and then you can set the range by that %10, and then the offset by adding like this one. So in our case, though, like we said, it would be rand parentheses, and then % 1401 plus 400 for that range, which I still think is a weird range to do.
Okay, so the 1401 comes from, if you look at the assignment right there, see the 400 to 1800? The range means to subtract those two numbers and then add 1. And
Yeah.
that's like the formula for doing that. I got real confused on that too, because I thought it just wanted me to pick a random range between those two numbers, and it didn't work when I did that first. So I feel you on that 100%.
Yeah.
Okay.
And honestly, I would have done like a range of like negative 90 to 90, or even like maybe negative 180 to 180 or something like that. That's kind of a range I would probably have picked, because it'd be nice because as it is, since it's always going to be turning, you're always going to get a positive number. It's always going to be turning in the same direction. Because the only way you're going to get it to turn in the opposite direction is if it's a negative number. Yep.
Okay.
But once again, yeah, that line 34 is what you would do to create the random number, and then they're kind of using it. In this case, they were using it in this movement function. but there's a lot of ways you could use that number. I mean, you don't have to make a movement function if you don't want to. You could literally, it could be your spin for, and that could just be how much you're spinning for. So you could say like spin for random degrees, and it would just use that random number for the degrees. Also, you don't have to name it random. That's what they called it here, but you can call it whatever you want.
Okay.
Yep. I have one of my robotics kids here today. I say kid, but he's a teenager. He probably doesn't like me saying kid. A few other ones should show up today too. That's
When
right.
when the age gap is far enough apart, they're all kids.
Yep. But now he's got the cumbersome task of clearing out that field. You saw what the field looked like, right? It was pretty bad. And now he's got to move all that stuff out of the field. Hopefully he'll have some buddies to help him in a few minutes.
Well, my field
Yeah.
is in pieces at the moment, and it's just stacked in a corner.
Mm-hmm. Well, we got the new game elements, but they're in the car. So I think that's probably the goal today is get the field cleared out and set up the new field. I think that's your goal, right?
Yeah.
If it makes you feel any better, Sandra, I took my field apart a couple of years ago because we didn't have the new gaming elements, and I haven't put it back together yet. And one positive to it not being together is you can move the squares around wherever you need them, and you can maybe even separate them out for individual groups to have them. That way, you don't have to have the whole floor. But
Oh, that's nice because my principal doesn't like it. My room's not big enough, so we've been put in the library, but our school has grown and now some of the PE classes have to go in there to begin with, and so she doesn't want it in the library, and I'm like, where am I supposed to put it? Because we have the old one where you have to unscrew everything. It doesn't just fit together, and I'm like, taking it apart and taking it down every day is just not going to work. So I don't know what we'll do. Might have to do
how
that.
much better is that portable field?
Well, it is a lot easier to set up. The portable field, that's one of it. It is not as durable. We've already had some pieces that kind of snapped a little bit. Oh, well, I tell you what, after one competition, my kids were really lazy in bringing it back here. They just kind of tried to keep the wall together and carry it instead of like stripping it all down. And that's what caused some of the breakages. So, yeah, at the joints. So definitely take it apart before you're moving it.
Like a few millimeters of plastic.
But it's got the GPS strip around it, and so because if your skills fields have to have the GPS strip on them, just in case there's a team that has that sensor. And if you're using a metal field, it's like a vinyl strip that you have to put up around it, but it doesn't really tack on very well. But it's actually it's a whole lot easier to transport around, and it stores really well because they give you these really nice bags to store it in. I personally like it. I like it a lot because it's really easy to put away when you're done. Because I gave away a couple of my metal fields, but I still have one left. But I really want to get rid of it too. I want to just move to all portable fields. Yep. And in fact, right now we have 2 portable fields. We're probably going to buy one more this year for when we host our competition this year. So we'll at least have 3 field sets. Yep.
Oh yeah, I asked around in the Discord who would Because that is a only a 3-hour drive.
Yep. So Ashley, when you flip those motors, did that fix that? Does it go forward now?
I haven't tried it yet, but I'm gonna try it soon.
Okay. So let's look at a bit about what we're else doing. So it's Friday. We only have a couple of days left. Let's see, Friday, June 13th. So we'll talk about the final project. It doesn't even mention going over Unit 11, so it doesn't even mention going over the vision sensor. But I would like to go over a little bit about the vision sensor, I guess. And then, so for your guys' final project, I'll give you guys a few options. Well, but first off, how about we look at let's look at the folder with the final project in it. Okay, so in this final project, it's a robot obstacle course. As it says here, students will build and code a robot to navigate through an obstacle course created by you. And do not tell the students what the course will be until the testing date. They should write code using functions and variables. On testing day, they would need to write their task main portion, so the main portion of their code, and pass the correct parameters to the function. Oh, Logan's here too. Okay. So, and it says positive behaviors prepared. So, like auto straightening, precise turning, obstacle detection, using a manipulator, and ideas for course elements like ramps, a maze or a complex path, obstacle course, object scoring. And the idea with it is that you're going to set something up. The kids are going to like spend like maybe about a week writing functions to perform that task. So they'll kind of know what the individual tasks are, but they're not going to know how they're put together. And then on the day of, then you're going to show them the full thing, and then they're going to like take their functions and put them together and do it. And basically they'll have like basically the idea is that they have to kind of have it done by the end of the day. So that's one idea for a final project.
Are these based on 50-minute class periods?
Well, yeah. So in here, it says she had 90-minute class periods. But if you have a shorter class, you may want to give them an extra day to do it. But with her 90-minute class, she only gives them 1 day. That's what it says here in the notes. So, however, you do not have to assign this project. You can actually come up with your own project, and especially that something that's more tailored to what you think your kids can handle. And even if you do this project, as you can see, there's a lot of variety because it doesn't really specify what your obstacles and things have to be. So you could simply make a maze for them to go through or something like that. So, and then here's an alternative final project. This is the one I was talking about before. the robot parade. So your class will be tasked with building robots for a robot parade for the elementary school. I put that in there because we're a K-12 school. And then so your robot will need to be able to automatically track and follow the robot in front of it while maintaining a specific distance apart. Your robot should also use at least one extra motor to perform some type of repetitive motion, such as waving at the crowd or juggling balls. We did have one robot that had a mechanism that like popped up a ball like up and down, and that was kind of neat. That one team did one year. And then the robot should also be decorated to make it stand out from the other robots. So kind of like a parade float. And so the robots must have a plate mounted vertically to the rear of the robot near the floor. It will serve as a reflector for the ultrasonic sensor. So in the past, so what we mean by that is on the back, it needs like some sort of, you want some sort of wide flat surface for that ultrasonic sensor to be able to bounce that signal off of. Or if you're using a laser rangefinder, it still needs like something on the back. Also, I can't remember what Vex kits it was, but some of the kits come with like these really big metal plates. And so they could just have one of these mounted on the back. That's what I did with the kids last year. And then if you do enough competitions, you're going to end up with like a ton of these like red license plates. And you could just stick one of those red license plates on. But if you don't have a red license plate, it could just be a red piece of tape or really anything red. Red is a really good color for the vision sensor because it picks up red really well, whereas other colors, maybe not as much. And so that's another idea. And what I do is I go ahead and I'll have like, because I usually have one robot kind of built as a demo bot. And I'll usually have the robot I built be the lead robot. That way everyone has to make their robot follow. So no one's really in the lead. Yeah, or we have the competition robot do it. Yep. So be in the lead. So that's and I find the kids really have enjoyed that project. And especially since they get a chance to like kind of decorate it and stuff, so they can show a little more of their creativity. And then we have like a rubric here for that you can kind of follow. But you're not limited to just those two ideas for the final project either. So for instance, we've had classes like some teachers, especially with their first year, they might have only gotten to the bumper sensor, and then they make the Roomba project their last project, their final project. And so those are also options you could do. Or I'm trying to think what are some other things kids do. Some I know some teachers, especially the ones that do competition teams, they'll have like maybe have their kids build a robot to kind of complete some portion of the challenge that year. And that would actually be a good one for this year because the objects are kind of small. So if their robot can like pick up the objects and then place them somewhere, that could be an interesting challenge to do. But the idea is to make something that kind of capstone everything off, and that allows the kids to kind of show off their skills at the end. Now,
Does each kid get judged on their individual abilities if they're doing it as a group project? Because I'm sure we're not going to have, I don't know very many people who have enough robots for every single kid to have.
yeah. Well, the final project is a group project, and it will be graded as a group. I guess where their individual grade is going to come in is the final exam. Yeah. So that will kind of test their individual skills, because if they've been slacking off with the project, they're probably not going to do too well on the exam.
How do you get kids to, or I guess not cheat on the coding part? Like, I'm just imagining kids like sharing their code with like in the entire class.
Yeah. It is kind of hard to spot. What a lot of times what I have to do is I usually crack down. Well, first off, I tell them that everyone should do their own code, and then when you do actually catch instances of it, then I crack down really hard on it. Like, give out zeros to not just the kid copying, but also to the people sharing when it's cut. Because man, because I've had kids turn in other kids' code without any changes at all. It didn't even change the header. Like, it still had the other kid's name in it. But once again, I would make it clear to the kids that if they are caught, then everyone involved gets a 0, even if you did it yourself. Because what you'll kind of find is the kids that do it, and the kids are more likely to get asked to share the code, are the ones that are really concerned about the grade. So if you make it really clear to them that if they are caught sharing, even though they did it, if they share it with someone and they're getting a 0 too. And then
can I jump in real quick, Eric?
Sure.
So a couple of things. One, this year specifically, just for fun, I definitely had a cheating cabal in my robotics class, and the way that I found it out, well, there's a couple of easy ways. Number one, a lot of times they may not cut the header, because I'm very careful about the headers, and they know that. But what they'll forget is they'll leave the int main, and so they'll cut the int main and they'll paste it, and they'll end up with 2 int mains in their robot, and it won't work, and they can't figure out why. So the moment they bring that to me, I'm like, so why do you have 2 int main? Well, no. Sometimes it's legitimate because they will have basically cut code from another one of their projects they're working on. You have to be careful. But the one that I caught recently was, I went up to, so I do things a little bit different. I check code, I don't get them to turn in code. I check code after they do it on their computer directly. And I use a Google form to do the checking. It saves me a lot of time. And during robotics season for FRC, I just don't have time to sit at my desk and check code very well. That's the first thing. But beyond that, when I went to check this kid's code, he had a Google Doc open, and he really quickly switched to the code. And I was like, So I went over there and I opened his Google Doc and I looked at it, and it was the code. And I went up to the shared with, and it listed 7 kids' names that it was shared with. And they all got 0s, all got written up, all got sent to the office. But when it comes to final projects, my final project I end up doing is more of a maze style thing, or I have them go through a maze or something like that. And what I do is I give each individual person, because I'm grading it individually for me, not doing a group, each individual person gets their own way of going through the maze. It's the same exact project base, but some of them have to go up here first and then down here, over here. I just make it difficult enough to where copying the code doesn't make a lot of sense. And that helps in some ways. Just changing small variables within it can help a lot, because they're having to write something different anyway. And that I find helps out a lot. And then the other thing I do is if I notice in a certain class that it seems like kids are copying from each other, I may throw in there a random assignment where I'm getting them to write code that's just that I'm not going to ever have them run on the robot. Literally, I give them tasks to run and I say, here, do these tasks. And I give it as a test. And I make them type up the code. And suddenly you find out who really doesn't know what they're doing.
Yeah.
And you can have your Go Guardian up too.
If
So
you have that.
like
Some
if you
people have it,
got
some
if you
don't.
got Go Guardian or some sort of monitoring software, like you can, especially if you're worried about like them going to like AI to try to write it, like I'll have my Go Guardian like up on the board and like they're quick to be like, oh, more like, you know, somebody is on. I'm like, oh, really? Click off. You're done. So it takes a lot of monitoring, but yeah.
Well, and in another, well, I mean, y'all have kind of alluded to it, but most of these codes, I would think, are going to be very similar since we're teaching them something that's going to basically be the same for everybody for each individual project. So, I mean, they might not be identical, but they should be close. So, as far as cheating in that aspect, it's going to be kind of hard to tell. I mean, unless you're just like y'all said a minute ago, just being active about your checking in on somebody. Like you just walk around checking and, hey, what you got going on there?
Yeah. And yeah, and it is definitely going to be an issue that pops up. Yep. Because kids these days, they're just terrible.
They'll work harder not to do the work than actually just do the work in the first place.
Yep. But yeah, but that one suggestion was really good. Like if you're doing the maze, you could have like assign each person a different starting location and ending location in the maze, or so that would be an interesting way to do it. Or like you said, if there's like different checkpoints in the maze, you can have those in different order, and just kind of randomize the order for each person. So those are some great ideas, at least for going with the final project. Yep. So yes. Okay. So let me just look at what. So finish the unit 9 and 10 activities, individual meetings for questions if needed. Okay, so for us, or should I say for you guys, what's your guys' final project going to be? So I think I already said for Ashley that she was fine just doing the Roomba project, just taking a video of your Roomba code or your robot doing the Roomba and showing it off, and you can use that as your final project. And anyone else that wants the Roomba project to be their final project, we could go with that. Or if you want more of a challenge, we could try to maybe set another challenge. Like for instance, maybe use the ultrasonic the range or the distance sensor, and maybe see if you can make the code your robot follow another robot or an object in front of it. If you want that to be your challenge, that would be a good one. Well, obviously, I'm not going to tell you guys have to put together a maze in your house and make your robot solve a maze, because that's a little bit much for work.
So basically, do unit 10 activity too.
Yeah, that could be your final if you wanted to. Unit 10 activity. That was the one where you had to. It had to kind of follow. And that would be a good one. Or one thing, it didn't mention the slides, but we didn't go over the vision sensor at all. We could go over. We probably should go over Unit 11, because a lot of you guys are probably going to at least try to do Unit 11, maybe. maybe not everyone. If you obviously if you don't have vision sensors, you're not going to do Unit 11. But we should make our final project something that involves sensors. But the Roomba would be fine, especially if or you could do the following robot.
If you
Something
don't
along
have a
those lines.
vision sensor, could you use like an optical or something like that where it has to recognize a color? So like maybe you send it and it has to go around until it finds the color that you assign it or something like that. Roomba-esque, and then it kind of pinpoints whatever it's looking for.
Yeah. I guess yeah, so you could try to like tailor a challenge to what you can do. So for instance, it could go up to an object and then check what color it is, and maybe if it's one color it goes one way, and if it's another color it turns the other way. That could be something you could do. Just challenge yourself. That's what I want us to do. Like, so if you want to get ambitious with it, then get ambitious with it. But if you, I just want you guys to challenge yourself, but not to do something that's so overwhelming that you don't think you can pull it off. Yeah.
Is that similar to how the maze would go? If you did the maze? Or you have to follow a color pattern or follow some kind of shape pattern or something like that?
Yeah. So with the maze, there's a lot of ways you could do the maze. For instance, it could be just like you mark it off with tape, and then you just tell the kids that they can't like cross the lines. Or if you had like physical walls, you could set up like if you had like a lot of boxes, or you could set up something physically so that the robot can like bump into it, or use the ultrasonic sensor so it's not hitting the walls. And you could kind of go that way. Like for instance, if you one year, what we did is the kids didn't actually see the maze, and it was basically I just had walls set up, and it was relatively simple, but the robot, they had to like write a code, and we had like a lot of sensors, so they had like multiple like range finders on their robot. So they had like one in front, but they also had one on the left and one on the right, and basically it had to use that data to kind of find its way out. And so and it would, and the easiest way for it to do it was to kind of like not set it straight in the maze, but kind of have it at an angle, and so it's kind of go until, so it kind of like bumped around the maze to kind of get out. But once again, just the idea is just to tailor to your challenge. And in fact, in that class, we had vision sensors too. And for the students that were kind of really struggling with it, what we did for those kids is one neat feature of the vision sensor is you can set it to send out like a Wi-Fi signal that you can actually connect to with your phone to actually view what the camera's seeing. And I had the kids that were kind of struggling. They had to navigate through the maze, but just using a camera and not seeing what the robot was doing. Not actually being physically in the same room with the robot. They had to just drive through it just with the camera feed. And I think I made them. They had to pick up like an object too, and deposit it somewhere. But that was kind of more tailored to their skill level. But that was a neat challenge for them. So the idea for our final project, we want it to be tailored to what you can handle, but make it somewhat challenging. Yep. So, okay. Now that I'm back in my room, I do feel bad for. I've got Hunter and Logan in here, and they're working hard, clearing out the field. Really, they're just spreading the mess because the mess was all concentrated in the field.
I keep telling him, and he's like, "No, we'll get to it. I'll get him to do it later."
Okay, I have 2 errors that I can't figure out.
Sure. Yeah. Feel free to share your code, and we'll look at it.
It's here and here.
Okay, let's see. Right motor.
Yeah, a closed curly brace about here or something. If this one is in degrees, shouldn't the right motor be in degrees?
Okay. So there's a couple of problems.
Okay.
Okay. You're saying left motor position degrees, but right motor you're saying set position degrees.
Oh, okay. I got you. Should this be?
No, they should both be position, not set position.
Okay, I got you.
Because you're not trying to set the position, instead you're trying to get the position off the motor. You don't need the square, that square bracket.
I didn't know I did that. Okay.
Yeah. And then, where is? Okay, so you have this go back. I guess you're not finished writing your go back, but it is true that you need to close off that brace somewhere.
Okay.
Yeah.
Like maybe here.
Yeah.
All right.
And see if that builds.
Yep.
Okay.
Oh,
So now the problem.
Still there, but.
Okay, so click on that open brace after feet and see where the close is going. Okay, so saying the close is going there. So where's that other close going? Oh no, it's closing there. Okay. Where's the closing brace tied to with the movement on line 136? Click on that closing brace.
Or this one.
Yep. Click on that 136. So that's close. Okay, so get rid of the one on line 138.
Okay.
Okay, another problem you're having is you're not supposed to make your functions inside event main. So you need to copy or cut out all of line 129 through 132.
Yeah, all of those crates and put them right here.
Okay.
Like select it all, including 132. And that all needs to get pasted above that main.
Oh, I didn't copy that. Okay, so it's got to go up here.
Yeah, above that main. So like on line 114 or yeah. Because anytime you make a function, it's got to go above it. And then don't forget your closing curly.
So
okay. Yeah, that's a tough one.
and then we're going to close it.
Yeah.
Yes.
Okay.
Old building.
Do I need to get rid of this one?
No.
Okay.
See if that builds. Okay. Movement. Do you have a function? Okay, you don't have a semicolon on the end of that line.
Oh, this one.
Okay. Could you scroll up a little bit?
I may not have named it or declared it. I mean.
Well, okay, so you made this function called movement, but notice that your movement function you're taking in. Okay, basically you need to do to your movement what Josh did to his movement, which is clear out, go to the function movement. So scroll back up a bit to where you said void movement. So a little higher.
Right here.
Yeah, so like 105. You need to delete all those parameters because you're not using them. So everything inside of there, inside the parentheses need to go. You need to put the parentheses back.
Okay.
And you also need to put the open squiggly back. Okay, and so
do I get rid of the closed one?
Yeah, get rid of the closed one. Yeah.
All right.
And then on line 110 and line 111,
okay,
instead of turn dist, you're gonna put random because that's how much you want to turn by.
Oh yeah, okay. I'll put it from I hope my kids are better at this than I am.
Yeah, and it's rand with a D.
Oh, I forgot.
And make put a negative in front of the random on 111. Yeah.
Okay.
And honestly, you don't need lines 108 or 109 anymore. Am I in your way? Okay.
Yeah,
Do you just want to set it right here for now?
yeah, that's probably best. We can put it up.
Okay.
Okay.
It look like I'm ready? I don't know.
Another thing, you're going to need to encapsulate what you're doing in a while loop. So like on line 120, for instance, you're going to want to start another while loop. And the condition is just going to be true. And you're going to so delete the closing brace on 122.
Okay.
Instead, you're going to move it down to like line 136. You'll put that closing brace at the end because what you want to do is you want that whole thing to loop.
Okay.
So you'll close it down there.
So here.
Yeah.
Okay.
Or you could do one on line 130. Yeah, you're going to need one more. So you can put it on line 137 if you want, but you need another closing brace down there.
Okay. Oh yeah, there we go.
Okay, and then there's more. Okay.
Oh Jesus.
Okay, on line 126, you're saying while the bumper's being pressed, you're going to go forward. That's what you have there. But what you really want is while the bumper's not being pressed, you want to go forward. So you want to use that not sign, that exclamation point in front of bumper A.
In front. Okay, gotcha.
Yeah. Yeah. So while it's not pressing,
okay,
and you want to go forward. Okay. And then you can try that.
Okay.
I'd say you would set one in there, right? You would set one in there.
Hey, we just got this room all clean and you're tossing stuff. Don't do
I
that.
don't think they're going to show up.
You don't think Toby's going to show up? Or Ryan?
Well, I think. I don't know. I called her. I don't know when we called him. But Toby.
You want me?
Toby's gonna wake up.
You
Call
want?
his mother.
Yeah,
Call his mother.
I'll text Toby's mom.
Tell him to. I'll go get him. Because Logan, there's enough here. Here, this is mostly metal stuff. Come put this up. Text Logan. Text Toby's mom. I'm not gonna get him. But yeah, that's all just. Somehow. Like, we need that,
You could start setting up the shelf.
yeah, most of us. You gotta go on that shelf.
I'm a really slow texter. So okay. So did it work, Sandra?
I've got it loaded. Couldn't find my cord. So I
Okay.
got another one. But I'm about to test it.
Be careful about don't step on those because you'll shatter that plastic.
But it's film, Evan.
Yeah,
How's it
and they
shelf?
made it out of a
Well,
shell of plastic.
Well, even so, you can snap that plastic. I mean, it's not meant to support your weight.
You texted Toby's mother.
I did, but
I'm here.
honestly, she might not be up either. She's known to sleep in late, so especially since it's summer.
Text the whole family.
Text the whole family. No, I need to text Toby's dad. You're saying?
Get him up. He's supposed to be here 30 minutes ago.
That is
37 minutes ago.
all right. I'll text Toby's dad too.
He's already through it, and he won't work on the notebook. I'm gonna need discipline. Wait. He works on the notebook. You were true, and you don't work on it, actually. This
So, how did it do, Sandra?
look right here, buddy.
Okay. So what did you tell Ashley about the because it's going in the wrong direction? Like
Oh,
this,
okay.
my front is with a claw on it, but I had to put it on the other.
Okay, so to just go into the motor and sensor setup, the devices. It's the button looks like a phone port. Yeah, and just click on left motor and put it to normal,
Okay.
and then right motor will be reverse.
Okay. I was thinking it would have been the opposite.
Yep.
All right. More time.
I still think you should do redo, but like spelled French. What, like
That's almost French.
yeah.
I've got to put it a little further out because my gear for my arm is
It's
little
getting in the way of.
But I did press the button and then it started spinning.
That's a good sign, right?
It didn't it didn't back up, it just started spinning.
Oh, it didn't back up at all?
Well, it backed up a little bit and then started spinning.
Okay. Did it ever stop spinning?
When I turned it off, yeah.
Oh.
I don't know.
Okay. Well, it might. So the spinning would be in your movement. Did it actually print a random number on the screen?
Let me see.
I don't even know what this could be used for now.
By the way, your go back function does not actually go back. No, all your go back function does is print that it's going back, but it doesn't actually do that.
I got you. Oh my gosh, I'm terrible at this. Okay.
Well, okay, but so you see where it says void go back?
Um, oh, so I got to put in a number.
No, you
Okay.
don't. But do you see the code that's inside that function, right? It's only those 2 lines of code.
You talking about here on 112?
Like lines 113 and 114,
Uh-huh.
that's the code for the function,
Okay.
but all it does is print to the screen and then do a new line. It doesn't actually go back at all. It's saying it's going back. It's saying go back feet, but it's not actually doing it. So
Do I actually put a number of how many feet it needs to go?
well, you need to put a couple of lines of code to actually make it move backwards.
Oh,
Like you could use just the spin 4 command if you wanted to.
okay. Do I put it underneath here?
Yeah. So you could say like a left motor spin 4. And if it's backing up, you probably want reverse, yeah. And then comma, and I would just probably say feet, comma, turns. I would just do turns. Yeah. Now it's not going to go forward 1 foot. It's going to go. Well, it's going to go backwards 1 turn, and that's all right. Also, at the end of, you need to do a kind of comma and a false.
Oh,
Because if you're using spin 4, you want to put that false in.
do I put faults here too?
No,
I don't think so.
just on the first one.
And then close parentheses with a.
Yeah. So see if that builds.
Okay.
Well, I texted the whole family, Hunter, and no one has responded to me.
They're all asleep.
Yep. I guess I should text Timothy next. Get all my bases covered.
Yeah.
I guess I could. I don't think I have their grandma's number.
Dude, whoever screwed this in, they. Actually, yeah, the nut driver won't fit.
Okay.
Impact driver.
In this build.
What time are you guys staying till?
So what?
What time are you guys staying till?
We might have to do some later.
Sure. Oh, 4. Never mind. I see what it is.
Apparently, Toby didn't tell anyone that he was supposed to be going to Robotics today. He didn't tell his parents.
Have they responded?
Yeah, they're just now responding.
Do they need me to go get them? Because I can. If you just drop his address, I can.
Okay. They're both like, okay, the first I've heard about it.
Bro. He probably forgot. Let's be honest.
Yeah.
Let's be so brutal.
Mm.
It's okay.
Mhm.
I see you sorted the brain then.
Yep.
Oh, where does this go?
Woo, we got it.
Good job.
Oh, so it's working.
So it when the bumper was pushed, it went forward a little bit and then started spinning. Is that
Okay.
what it's do?
Probably a bit.
And did it ever stop spinning after it started spinning?
No.
It just kept spinning and spinning and spinning.
Yes.
Okay, well that might be an issue. We probably need to fix that issue. So
Okay.
that would probably be a problem with the move. Let's see what your movement function looks like. Are you sure? Did you give it enough time to finish? Like it might just. Yeah, it's gonna go a very long time because you have your set to turns, and like for instance, like 1,400 turns is gonna be like
Oh,
1,400 full rotations of the thing. So you probably instead of turn, ooh, what was that? Oh. So instead of turns, you probably want to set that to degrees.
okay. Oh, where'd that go? Degree.
Or you looking at a cheat sheet there?
Ryan, yeah. I have like this is
Yeah, because 1,400 turns is a lot. So it at 1,400 turns, it might spin for like a couple of minutes before it finishes spinning.
I mean, it's all coming together. And eventually, I guess I'll get better at it. It's just going to take some practice.
Yeah. Yeah. Miss Young said probably. Yeah. Is he coming now? Oh, do you want to go get him?
Yeah, give me his address. Oh, I'm up to pole. You can late. You keep sorting stuff up. You need to just go through that one. Okay, well, that's odd. You really good stuff to go with that. Like that. That tray, we're gonna need that thing up.
Okay. So, it went forward when the bumper's pressed. Backwards, it spun, and then it went forward again. And then I pressed it again. It did the same thing.
Yeah.
What's to do? It's acting like a Roomba, I think.
Yeah. Yeah, that's what we want.
Okay.
Okay. So Toby's not awake yet, apparently. Were you calling Toby?
He got a weird voicemail sentence.
So I guess we looked at everyone's but Raven's. How's yours, Raven?
I can pull it up. Hold up. Let me share my screen.
And by the way, like the way that like Josh and Sandra did it, that's not the only way you can pull it off. I mean, it is a way, but there's lots of ways you could do it. Like, is this your Roomba code or is this a different code?
It's the Roomba one.
Okay.
Oh shoot, hold on. I don't know. All right. Look at you guys. Okay, so I know that I have to go forward.
I put the screw in over there beside the Husky.
Okay. So
I saw you hold the lid and I was like, do you remember
okay. Sure. Okay. So
last year? That dude
do you
dropped their whole bucket of screws.
do you okay? So I saw the part where you're going forward. All that code before the fur, like all your while loop and all that kind of stuff.
Everyone in the room felt that.
Do you actually need all that code?
I was looking at this assignment where it says we can, I think it's this one. We can use the auto straightening code right here.
Okay.
Well,
yeah. Well,
yeah, over here. Okay.
Yeah. So I think it's just saying that you could have used that, or you could have done what they were doing.
This year, Logan, a lot
So
of what you're gonna really need to get good at is sitting still.
So I technically don't need like if
Knowing
one motor is running, you know, slower than the other.
if we can
yeah.
pull
So I mean,
a
you don't ne-
long goal,
you don't necessarily. It doesn't necessarily have to auto straighten. I mean,
Okay.
and so if you wanted to, if you didn't want to delete it, you could just comment it out. Do you know how to do a block comment where you comment like a lot of stuff out?
Oh, would it be just the
So
2 slashes or how do I do that?
so instead of so let's scroll up a little bit.
Okay.
So you really don't. So honestly, on line, say 94,
Okay.
do a slash and a star, like the star that's above the 8. And then on, let's scroll down a little bit. So notice how that like commented out all the stuff. And then on line 118,
Mm-hmm.
let's do a star slash.
Okay.
So that commented out everything between those two things. Because we really didn't need all that. Because all you really want to do is like while it's not being pressed, we want to go forward. That's what you've got.
Mm-hmm. Right.
And then we're stopping and weighing a bit. And then we're going backwards is what you're. Okay, let's scroll down a little bit further. Yeah, that is kind of code for going backwards, I guess.
Okay.
We could have done it simpler if you wanted to, but we can work with that. What you got? So let's keep on looking down.
Okay.
And then you're creating a random number. And then you need to actually turn a bit. So after that random number, let's just do a spin 4. Like a left motor spin 4 and a right motor spin 4. Dot.
Yeah.
Spin 4. And let's do forward, comma, random. Kind of like how you said, like that random, like you declared in 153. No, just a random, like a and yeah, and then comma, degrees. And then let's do a comma false.
Okay.
Okay, and then we'll do the same thing with the right motor, but we just won't have the false on the end.
Oh, I know mine is working. It's working. There's enough holes in it.
And semicolon. Now, can we scroll up just a little bit? So, okay, well, that's too far. So where you have your while, okay, so that while loop, you need to have a open curly brace on the end of it. And the closing of it is supposed to be at the after the last else after. So scroll down a little further. After the end of the L, so like on line 152, for instance.
Oh, here.
You want to let us go get the field stuff out of your phone?
Sure.
How much is it? How much is it?
There's a card in there. It's basically all the boxes that are in there. But there's also a card.
It's already in the card?
It's not already in the cart. It's in the bag. Just don't grab. There's a chair in there. You don't need to grab the chair, but you can use that cart that's in there to grab the stuff. Does that build now? Yeah, looks like it didn't have any errors. Okay, and that's pretty good. And the only thing that's really kind of missing now is you want. Right now, it's not repeating over and over. Right now, it's just gonna go forward till it hits it. Then it's gonna back up and turn, but it's not gonna do it again. So to make it do it over and over again, you need to encapsulate that whole thing in a loop. And so what you'll need to do is you'll have to kind of go up to where you first started. Like right before that. So maybe put a, yeah. And we'll do another while loop. And the condition is just going to be true because we want to just repeat over and over and over again. And then that closing brace that's like on line 21, you're going to move that down to like at the bottom, basically. Like all the way at the bottom of your code. Yeah. And see if that builds.
Yes.
Okay. And that should make it repeat over and over and over again. And hopefully that will work. You'll have to kind of load it up and see.
That's right.
And I guess, Josh, you're trying to tackle the following stuff, right?
Yeah, I did 10-1. I got it to work with my distance sensor. And now I'm trying to modify it for 10-2 so that it can follow the object.
Okay.
So I'm piddling right now, trying to think in my head what I need to do.
There are a couple of ways you could do it. You could do it with
I was
if
thinking of
statements.
setting it as an inequality.
Yeah.
And as long as it's like, go ahead.
Yeah, so you could do it with if statements and inequalities. Like if it's like less than 10, go forward. If it's greater than 10, go backwards. Or something along those lines. Or
Would it be the opposite?
Oh yeah, if it's less than 10, you want to go backwards. If it's greater than 10, you want to go forwards. Yeah, that's true. If you're going to do it that way, I would suggest kind of having a dead zone there. Like
Yeah,
if
I'm
it's
doing 11 and 9. I was thinking of greater than 11 or less than 9.
Yeah.
And then I also have to do the less than 0 thing still because it potentially could get out of the. But I'm using a distance sensor, which I assume that it'll return the same thing if the laser never gets anything to reflect back. Does it come back as a -1 as well?
I'm not entirely sure of that, but it wouldn't hurt. I mean, it doesn't hurt to have that in there because even if it doesn't return back a -1,
Right. It
Yeah.
just doesn't do anything.
yeah.
What is that? Ink?
Hmm.
Oh, yes. Oh, they're so neat and organized.
They are really neatly organized. I want put these back straight. I want the drink when he gets a chance to look because
That feels gross.
the ball.
Did Toby ever text you back? Or
Yeah, I gotta go back.
okay, did he text you his address? Okay,
Jamie, like,
yeah, Jamie Lane. Do you still have my keys? Because I would like my keys back. So, the other way you could do it is you could do proportional control. And the proportional control does it a little nicer, because like if with proportional control, if it's really far away, it will like rush up to you, but then as it gets closer, it will start slowing down. But yeah, I like what you've done with it, encapsulating the whole thing in a big while loop. And I see you're auto straightening while you're doing this.
Trying to, yeah. All right. Else.
By the way, it is 10 o'clock now. Do we want to take our 10 o'clock break or?
Yes, I'm going to
Love a
finish.
break.
Yeah.
Okay. All right. Let's try a 10 o'clock break. And for those of you like Raven, if you haven't tried that code on your robot, see if you can load it up in your robot and see if it works. And I'm gonna check on my students for a minute.
Can I just do else with the open close, or do I have to input?
Yeah, else does not have a condition with it. But you want to
What
do
is
an
it?
else. Well, you need an else if.
Oh,
So else space if. Yeah.
and then I do the less than stuff.
Yeah. And yeah, and like you have, in that case, you don't need the or less than 0.
Right.
Yep.
It's what's it?
Okay, so you need to close off. No, it is a space. It's else if. But on line 149, you do need to close off your if.
Oh, it's here. It's down here. Yeah.
Yeah, it shouldn't be there. It should be on line 149. Yeah.
Now, whenever I inputted it, I accidentally grabbed it, I think.
Yep.
Yeah, I accidentally grabbed it a minute ago.
And then you're going to want to else, and you probably want your motors to stop, right?
Right. Yeah.
But that was definitely a good idea coming up that dead zone for sure. And yeah, else doesn't need the open close parentheses. It's just else. You still need the open curly, but you don't. Yeah.
Yeah, I got you. It didn't have a condition.
Yeah.
Well, so could I have done, if I would have done else here instead of else if it's not greater than 11 or less than 0, now I still needed the condition for less than 9 because otherwise it would have just been anything other than that. It would have gone
Yeah.
backwards.
Yeah.
Okay. Which,
Yep.
I mean, realistically, I guess that actually would be accurate too. If it were less than 11, I mean, I could have set that number to 10, I guess. And if it were less than 11, it would have gone backwards. Or 10, I mean, I'm sorry. Couldn't you have done that? And if you're doing this type of controller movement, that takes into account the issues with the really fast adjustment, and now it's proportional, right? So if this is now 10, and then this is just an else statement, anything that's not one of these two would be encapsulated here.
Well, not really, because those speeds are just proportional to the left and right motor positions. They're not. Yeah, they don't have anything to do with the ultrasonic sensor, the rangefinder.
Okay.
Like if you wanted proportional control, you would have your speeds proportional to the rangefinder. Like your error would be not like left motor minus right motor. Instead, your error would be your error could have been like
distance.
It could have been your position minus your target value. Gotcha. So it could have been like your distance, your distance minus 10 could have been your error. Yeah.
Okay.
Yeah.
All right. I want to take my break and I'll test it out.
Okay. I'm going to take a break too. I'll see you guys in a second. Oh, my back.
Now only sent us 4 calls for green.
Yeah. There's only supposed to be, those are the 4 center tiles, right?
Oh, I guess.
The ones with the fancy logo on it.
Yeah.
Look at all kinds of stuff here. These fancy loaders. And that's just a nice little rubber. Rubber. Yeah. Guess we need to follow the instructions. There's one of the boxes should have like a QR code on it. No, it would be like on an inside flap. least that's how it was last year. Excuse me, sorry. Oh, this right here is just a welcome kit anyways. This is one extra ball.
Just one.
Yeah. And we got more license plates.
Oh, yay.
Yep, even more licenses.
Why'd they take the TV? That you don't need it no more?
I'm actually wondering about that myself. I wonder if they, and also, they took one of my chairs. They took my good chair. I'm kind of wondering if they put it in some of those.
FYI, if you run that program and then you pick up whatever object you were putting in front of it, the robot will start to chase you. Actually, I liked your slides, by the way. Your Quizlet, I mean.
Oh, Well, that's good. Hopefully it helps.
Question, y'all. Okay, my brain says something about updating. Now it doesn't want to come back on at all. Do you know anything about that?
Yeah, this is a nice
Stormy,
Is
give
it
me
still connected to your computer?
Yes.
It's not saying anything?
No. It popped up on my computer that it was updating. You know, the bar went all the way through. It said completed. Then my little brain, it like blacked out and now it doesn't want to do anything.
Hold the power button. Will it come back on if you hold it for like 5 seconds?
No.
Check your battery.
Yeah, I just it was charging, so it's good. Yeah. It's all fine.
That is an Eric question because I thought
Yeah.
it should have popped back on once it finished its load.
Update.
it is storming where I'm at. Is it storming anywhere else?
Yeah, it's storming here too.
It's just me and my principal, so
It's yicky all around.
yeah.
It's been bad here the last couple of days.
It's not in New Orleans yet, but I'm sure it's coming.
It's raining pretty bad here too. Well, it's not raining right now, but it was. I stole a chair, or I upgraded my chair. Because
I have a question.
yeah,
Okay, so whenever I went to like I guess you would say start my program, said that my brain needed to be updated.
okay,
So it updated on my screen, my laptop. It blacked out, like the brain actually blacked out.
Okay.
And now it doesn't want to come back on at all.
The brain doesn't want to come back on at all?
No.
And you're holding. Does your battery have a charge to it?
Yeah, it's good.
Okay.
It was on a minute ago, and then once it did the update, it blacked out and it doesn't want to come back on now.
Okay. Hold on. Yeah, I think. Like you typically want to be pretty careful when you're updating firmware not to turn it off prematurely. But I was
because the screen did come up and it said it will black out or whatever, and then it blacked out and now nothing.
See if you can.
Oh, here we go. Okay. All right.
Oh, good. So it came back up. So it came back on.
Yes.
That's good. Let's go down. Let's do.
I was telling everybody that if you're doing that second unit 10 deal, and you take away the object that you have in front of it, it'll start chasing you. So just be careful.
Yeah. Yep. Yeah, and since there's no speed control there either,
I'm
it's
about
gonna
to
go
try
at you
mine
at full
out.
speed.
I'm about to try mine out, so hopefully I don't lose an ankle. It's a little ankle biter.
That would be a good name for the code. Call it
Yeah,
ankle
it
biter.
didn't dawn on me that whenever I had an idea like, okay, I don't want it to come up me, so I'm going to put something in front of me. I had that idea, and then I went to turn the code off, and natural reaction is to stand up and pick up whatever I had in my hand, and they start coming after me. And I was like, whoa, wait a minute.
Yep.
I see no setup field though. Why isn't it finished?
Hey, Toby, did you just wake up?
Yeah.
Yeah.
Hey, these are interesting.
They've been talking bad about you, Toby.
Yep. I've been
Okay, so all of them were lying. It doesn't fall straight out, even when it's not on the wall. Okay.
Oh.
Maybe if you drop it.
It's not if you drop.
If you put it against, if it's open like this,
I don't think that rubber thing's on correctly either because it looks like it's got an angle to it, or unless it's supposed to. Yeah, it wasn't on the wheel. I did that actually.
What is that?
What is that?
Chicken nuggets
Okay.
and turkey.
Where's the screen?
Oh,
Yeah, they took them all down in all the rooms. I don't know if they're.
yeah, good ones. Oh, let's do it.
You'll probably have to pull up the instructions on your phone because we don't have a screen to pull them up on.
What is this holding down?
It might be holding down the smaller ones, maybe. Let's go. Just come right out, isn't it?
Since it's proportional control, will the robot should turn if the object moves and turns, right? Because one side will try to catch up to the other side.
Well, honestly, if I was doing the proportional control for that, I would have just both. I would have both sides move at the same speed. And so I wouldn't be trying to do it like an auto correcting there. Now, like for our parade bot, basically there were like two components to the adjustment of the speed. So there was like a kind of a forward and back adjustment that was affected by the rangefinder. But then the left and right adjustment was actually affected by the vision sensor. By if the red object was in the center, then that would be 0, and so forth.
So, like for me, since I don't have a vision sensor, I would have
Yeah.
had to do something like with the optical sensor. If it detects red, it finds red, or something like that.
Well, that optical sensor is a very close range sensor, so it's only going to detect objects right in front of it. Yep. I stole. Don't tell anyone, but I stole this out of Van Hoos's old room. I swapped out chairs. Yeah, Van Hoos is gone now. So
Isn't it like less than 10 inches or something like that? Or is it even less than that?
What are we talking about?
The optical sensor?
I don't know the specs off the top of my head. Do you have an optical sensor? Because if you if you do have an optical sensor, you can just plug it into a brain and then go to devices. And then if you have an object, like I'll hook one up. Let me grab an optical sensor. Here's an optical sensor. And now I just need a battery for this brain.
They gave us one extra.
Really? There's 89. You counted?
Well, the your welcome kit comes with an extra.
No, there should be extras in that box. I think it's 50 of each.
Really?
Yeah, that's what I heard.
Okay.
We're probably gonna have to lift these back up again. Put the plates down. Yeah, that looks so good. It looks so good, doesn't it, Ryan?
Yeah. You can't tell the difference.
You can't tell the difference at all.
No.
All right, I got the field assembly instructions.
They're putting together the new field right now.
Put all these caps on the foot tubes there. There's a hyper illegal part.
So I have one plugged in. What do I have to do to look for the specs?
On your brain, there's a button for devices. And then you should be able to select the port that's in. I hope you can hear what I'm saying.
Yeah, I can.
Okay. So, yeah, when you turn on your brain, you should be able to click on devices and then click that port.
So it looks like it's so for distance, it shows none. So now whenever I move my hand in, I guess I'm probably 6-ish inches away. It says far. And then about 4 inches away, it says close. And then less than 4 inches, it says near.
Yeah, mine's much less than that. Like I get none up until about, that's probably like maybe 3 inches away. I'm just using my hand though.
Yeah, that's what I was using.
That one. Is that one 180 or 0? I need to put it.
And I'm in the orangish, reddish color range.
Okay, so that's 0. I need to put 4-inch down.
Which is what my kids usually say. I look red. So
Here's this year's game object. So let me let's see if it. So it kind of shows a color hue. But I'm getting none. So I'll show what I'm doing here. So I've got like none out here, and then I get about here, and it reads far. Now it's reading close, and now it's reading near.
Oh wait, it has toolkits for it.
You guys sound like Grover on Sesame Street. Far.
Yes,
So
far.
it looks like I would have to be somewhere in the neighborhood of like 3 inches. So I'd put like
Yeah.
a stop on it or something like that, and then detect what color, and then go from there.
Yeah. And if you add that sensor, you can kind of see what you can see what commands that you have to work with. Like if you go in this sensing, for instance. So like so I'll share my screen. So like if we were to add a optical sensor, if we go over to sensing on the side, so we have these commands for the optical that we can kind of use. I mentioned before about it does have a gesture mode where it can kind of detect. And in fact, you can try out the gesture mode if you once again go into devices. And if you click where it says mode color, you can swap that to gesture. And then like you could try like swiping your hand in front of it or to the side and see if you can get the different directions to pop up. But I haven't had a lot of luck with it.
Because that one's going to go in the center. That's what holds that one plate right there holds the entire center goal.
Like,
stack. No, it's not. It's terrible. Logan, you're going to get that goal out there. We're going to tip the goal over.
let's not rip up our, especially not our practice field.
Not our field. The competition.
Oh, you're going to go to other schools' fields and rip them apart?
As a normal part of gameplay, so they can't DQ up. What is it? T8? I think it's T8, the rule against destroying fields.
Y'all are officially uninvited.
Yes.
Who's uninviting us?
Ditto.
They're passing that along. Yep. Okay. But at any rate, under the sensing, so with that optical sensor, there's a lot of things you can kind of do. There is an LED light which is really helpful to turn on, and so you have this optical set light power, so you can turn the light on and set how bright you want that light. But that's super helpful. Kind of like what Miranda was talking about with when they were using their vision sensors, having that ring light around it. Well, it's not a full ring light, but it is an LED, and that way you can get kind of more consistent colors there by using that light to reflect off of instead of just using the ambient lighting. And so if you look at these, so if you go by color, it's going to be like looking for a particular color. So like here's some sample code for that. So you could say like if optical color is equal to red, then we're going to print to brain a red object's detected.
And then right there, you could make a motion like turn to the right or turn to the left or whatever.
Yeah. Mm-hmm. So you could do that by color, or you can kind of go by hue, because you probably notice on the brain when you're messing around, I was kind of showing a hue number, right? And so you could maybe make a condition where like if it was between these two hue values. And using hue can kind of help hit more, because like for instance, like when it's picking up red, it's kind of basically saying that the hue is going to be like somewhere between this and this number. Then it's going to consider that to be red. And so if you have a red that isn't being detected by red, as red, then you may want to just kind of like go into devices, see what the hue of the color you're trying to pick up is, and then kind of like building your condition around that number if you wanted to. But
kind of make a range of from
Yeah.
almost like orange to purple kind of.
Yeah, exactly. So Sandra put in the chat, did you just use your code for the Roomba but change it to a rangefinder at the bottom of your code? Oh, are you talking?
instead of like instead of just change out the bumper switch to a rangefinder.
Yeah. So you can very easily say, so instead of like so for if you're trying to do a Roomba but with the rangefinder, instead of where you're where you're going forward while the button's not being pressed, you can instead say going forward while the rangefinder is greater than say 5 inches or something like that.
Okay.
Yeah, I commented out all the Roomba stuff except
Oh.
for my the part that I had for the the P control.
Mhm.
Okay, so yeah, you're not even using Roomba. Yeah.
Yeah, I'm not. No, this was. I just wanted it to. So this is the Unit 2 one. The Unit 1 would basically just be all of this except for instead of this, it would all go away, and it would just be stopping after it got to. I think it's 5 inches for the first one.
Yeah.
So the second one, it's got to be around 10 inches, and it wants it to go forward. It basically wants to keep it within a couple of inches of 10. And so I set it to where if it's greater than that distance, then it's going to follow me. And if it's less than that distance, then it's going to back up. And that way it just goes forward and backwards, trying to hover around that 10-inch range.
Yep.
And then I don't really know when it'll ever get to the stop, or how it could get to the stop.
Well, if it's between 9 and 11, it will stop, right?
Oh, yes, I'm sorry. Yes, that's what it was. Yes. Yeah, so it does just sit there whenever it's in our dead zone. I forgot about that.
Yep.
Because if we don't create the dead zone, and it mentions it in the slideshow, I think, or maybe it's in the activity itself, it mentions if you don't create a dead zone, it's going to it's constantly going to be moving.
Yeah, it'll just constantly be moving back and forth. Yep.
But yeah, I mean, this is basically the same code repeated, except I take out, so here I have a greater than 11, and then I have a less than 0. So if it gets really far away, and it returns that -1 value. This is under the assumption that it's going to do that with a distance finder. It'll do that with the sonic rangefinder, and I wasn't sure, so I just added it just to be confident.
Yeah.
But then if it's less than, I don't need that second part. And then there's a built-in dead zone between 9 and 11, so it'll stop if it hits the dead zone. And I probably should comment that in. Let's see.
Yeah.
Is that what you did?
Would you guys be interested in me showing you how to do that with the proportional control?
Yes.
Okay. I can, and it actually won't take very long to do, but I can show off that if you guys are interested. Sandra's got her. Is this yours? Let's look at. Let me click on Sandra's video. I saw Josh actually posted his.
This is the one that I did with the 2 feet, the 4 feet, the 8 feet, and the raising the arm, but it pulls to it wobbles a little bit, like.
That was a good song.
Okay. So it doesn't go in the straight line like I want it to.
I think it goes straight just until it stops, and whenever it stops, it's
Kinda wild.
sliding because the arm is going up or
Yeah.
down or whatever. It's sliding because
Okay.
if in between the stopping, it's going straight.
Yeah, yeah.
Yeah. It's going straight until the end where it's just kind of coasting a bit. When it's going forward. So it's really just at the end of those straights that it's kind of coasting. I mean, and basically, like one side is just coasting a little more than the other. Um, one one possible way maybe to try to fix that, you could try setting your brake tights to hold.
Okay.
Because if you set them to hold, it will actively try to maintain the encoder value.
We're picking the field up. Yeah, we're picking it straight up.
So-
We have to, like, take-
Yeah.
Or you could set your speed lower.
No, it came with tape.
It does.
So wait, does it go to 5 and then it's on the 6th one, or is it?
But what I was saying, Sandra, is if you set the stopping
It's tucked into, like,
to hold, it will try to maintain its position. So maybe so that way, if it coasted a little bit, it may try to go back. That may work. It may not. The other issue, you could just try going slower, and then it won't coast as much. So if you just crank your speed down a little bit, that's another possibility for fixing that.
This is fairly thick plastic.
Okay. Which I guess is not for this class, it's not a big deal, but
Yeah, but
we are
you'll
gonna be
definitely-
doing competitions. I'd like to be able to, like, fix stuff or help
Yeah.
them.
Well, and if you're on the actual robotics floor, it'll be a little bit more controlled than on
Okay.
your
Yeah,
your classroom floor.
yeah,
I know
because
when I did it on my, I have Mexican tile, and so they're very uneven, and it was just going crazy. So
Mhm.
that's one reason why I came to school today, so I could have a flat surface.
yeah, but yeah, and it's true. Those foam tiles
That's one of the center holes.
are going to provide a little more friction on the floor than just the tiles in your room. So that should help a little bit too with it not coasting so far.
And I did get my Roomba working, so the lights went out on me, but I'm gonna post that in there too, so you can see.
Great. So unfortunately, I don't have my personal laptop on here, and I just have my Chromebook up, so I can't access my personal account from here to set up the activity to post. If that makes any sense, what I'm saying, because the Google Classroom, I can't access it from my school account, and I'm at school, and so as soon as I leave here and I get back home, I'll put up where you can post your videos for today's activities. I just can't do it from here.
I
Okay.
got my ankle biter to work with the ultrasonic sensor. So the chasing one, we're good.
Awesome. That's great.
Did it bite you?
Well, luckily I have someone to be the dog catcher. So he picked it up for it to get me.
Okay, so I'm gonna I'm gonna write a new code for doing that ankle biter. I'm gonna call it ankle biter. That's just a great name for it. But I'm gonna share my screen, and I'm gonna write a full code from scratch. So we'll go through the whole process of it from scratch, and we're gonna use the proportional control this time. So that way, as it gets closer, it should slow down. And so you don't have to worry about like just running up and grabbing you. So we're gonna do a new text project. So I'm gonna just completely from scratch, and I'm gonna go ahead and name it. And I really like to name ankle biter, so we're gonna call it that.
wrong side. Wrong side. I didn't realize. I just looked up.
Ankle biter.
Communication is key.
You're the manager.
Mm.
It's
I'm
literally his job.
paying attention.
Okay, that checks out actually. Yeah.
So I'm just going to fill up my header like I always do, because that's just a good habit to get into. So today's the 13th already. And
It is actually. Cool. What's gonna happen to the field? Jake Reese is going. That's what's gonna happen. Yeah, for what? Oh yeah.
okay. So we're going to go ahead and set up our devices. So I'm going to, as always, I'm going to add a left motor and a right motor.
So
Miss.
that's right.
Won't miss again. That was a warning shot.
And I think I need to reverse my left motor. And
You're reversing which one?
I'm reversing my left motor, but
I think I had to reverse my.
once again, that just kind of depends.
Do you have a drivetrain? I'm sorry, gears on yours or no gears?
No gears.
So you're going to reverse your right motor.
Yeah. Yeah, my robot still has gears on it, but it also depends on what direction you have forward too. Because like you said, if you wanted if you had an arm on it and you wanted the side without the arm, you might swap that. Okay, but there's one device I forgot to add. We're going to add, instead of using the ultrasonic, we're going to use the distance sensor here this time, because we looked at the ultrasonic sensor before. But just to show you that it's the same way, and let's assume it's in port 3. I don't have it hooked up yet, but I'll plug it in port 3. Okay, so we have a left motor, right motor, and a distance sensor. Those are things we're going to hook up. Okay, so we're going to declare some variables. And since I'm doing proportional control, I do want to have a variable for error, and I want to have a variable for my KP. And those are going to be probably decimal numbers, so I want to make those floats. So I'm going to say float error, and we're going to start with our error being 0. And then float KP. I think 0.1 might be good for that, but that will kind of depend. But let's try 0.1 for now. I guess it honestly wouldn't be bad to have a speed variable either. So let's do another one, float speed. And let's set my speed to, unless you use, honestly, since I'm not going to do autocorrecting this time. And so let's actually just let the program control the velocity. So we're just going to use the velocities instead of using the voltages, since I'm not actually trying to autocorrect in myself. So we're just gonna use the speeds. Like we're just gonna use the percentages. Any other variable would be good to have. How about we have a variable called target? We'll call it target. And in this case, my target distance is going to be 10 inches. But that way, if I wanted to, I could go through and maybe I wanted to keep it like 2 feet away. Then I could set it to 24 inches or something like that. So I can have a variable to adjust my target value if I wanted to.
Gotta go this way.
So
Clear that. Yes. Clear that section.
those are some variables we're going to have. So in our main, basically, we want to encapsulate what we're doing in a while loop that's going to repeat over and over and over again. And so what we can do is we can say while true. And then I'm going to put everything, all my code inside this while loop. And that way it will repeat over and over and over again. And so every time I go through this loop, the first thing I want to do is calculate what my new error is. And so I'm going to just say error. And my error is just going to be my, what's it? Yeah, it's called distance 3. So, and it's going to be object distance. And the units will be inches. So whatever the object distance is, minus my target value. And this, well, I said 10, but I made a variable called target, so I need to use it. So if I'm 10 inches away, then my error is going to be 10 minus 10. And that means my error would be 0. If I'm 20 inches away, then my error is going to be 20 minus 10. And so that would be 10.
Do you have to define the target as inches or no?
No, no. Because it's that target is just that, it's just that number there, 10. Because we had to say inches or millimeters here because it's just going to spit back a number. But we had to say, but we had to specify so it knew what number to send back. Did it need to send back the number of inches or did it need to send back the number of millimeters? Because it would send back either one. But yeah, so we don't have to specify what target. Target is just 10. Now we know it's inches. So in fact, we could even make a comment out here at say this is the distance in inches, just so we know what that's doing. Just like we could say here is the speed and we could do that to all our variables just so that we know what they are. Error, we could just say is the difference between the distance and the target. And our KP is the weight of our error. So the bigger our KP, the bigger effect the error will have, or the bigger the weight it will have on the calculation. Okay, and we're very close to being done. We just need 2 more lines of code, and that is to actually set our speeds. So we're going to do motor spin, or left motor spin. We'll say forward. And then what our speed is going to be, it's going to be speed. And then it's going to be plus our KP times our error. Now, it might end up being
think your P needs to be capitalized.
Yes, my P needs to be calculated, and I also need to put on the N percent as well. Whoop. I don't need an equal sign there. And percent.
Eric,
Now-
do you need to have two P's on that KP?
No, I did not mean to have two P's. Everyone's pointing out all my mistakes today, but no, I'm glad you guys did.
We're just helping
Let's-
you out.
Yeah. Okay. So let's think through this, because maybe that 0.1 is actually might be kind of small. So, and also let's also make sure that the direction is the same. So let's work through a situation. So obviously, if my distance is 10, if I'm at 10, then it's going to be 10 minus 10, and that'd be 0. And then it's going to be speed plus 0. So it's just going to be our speed. That is not what we want. That is not what we want at all. Because if it's at 0, actually, we do not want a speed at all. Actually, we need to take out speed. I'm just realizing that now. Because we really want the speed to be 0. So we don't even need a speed as a variable. We want to take out speed. Yeah, we don't want a constant speed that we're modifying, because we want our speed to be 0 when it's at our target. Yeah, because that would have been a mistake if we had left that speed in there, because then it would have been traveling at 50 when we're at our target. And no, we want to actually be traveling at 0 speed when it's at our target. Okay,
We did say ankle biter, right? So that makes sense.
Yeah. Okay. Now let's do another situation. Okay, let's say we're 20 inches away. If we're 20 inches away, that means we want to go forward, right? How fast will it be going forward, though, is the question. So 20 inches away, so 20 minus 10 is just 10. So 10 times our KP is just 1. So it's going to be going at 1% speed. That's really slow. So that KP is really, 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 really way too low here.
You remember that was for when we were doing volts.
Yeah, so that was when we were doing volts, but now that we're doing percent, we need that to be much higher. Even if we set it to 1 at 20 inches away, its speed will only still be just 10%. So if we set it to 2, or
Should you think about it like when you're multiplying by a fact, like when you're multiplying by that, like if you're multiplying by 1, then wouldn't you want it to be like 50? I don't know. I'm trying to think of what I'm trying to say, but I don't think it's working.
Oh yeah. Let's try. Well, okay. If we're really far away, let's say we're 50 inches away. If we're 50 inches away, then 50 minus 10 is 40, and 40 times 2 at 80. Now we're traveling at 80% speed, which is pretty fast. So maybe we'll keep our KP at 2, but we can always adjust that behavior. Let's do it the other way too, though.
So we need to cap it.
Oh yeah, like don't let it go past a certain.
Well, okay. So one nice thing about this is if it's approaching something, it's not going to slam into it. It's going to slow down, even if it gets away from you and goes towards a wall.
Well, what I was meaning is that you could potentially go past 100%.
Well, yeah, but it will. The motor won't go beyond 100%. I mean, it physically can't go
right
above. So even if it gets a value of over 100%, it's still going to be 100%. So, So we don't really
Like
need to worry about.
if you're like 200 inches away, it's gonna be like rolling to get there until it starts to get closer and closer.
Yes, that's right. That's right. So if you're really far away, it's going to be running at full speed ahead. But then as it approaches, it should start slowing down. At least that's what we're hoping will happen. And then, but then, like, say if we're 5 inches away, 5 minus 10 is 5. And so that means it is going to back up, but, well, 5 minus 10 is -5. So then it'll have a speed of -5, which is actually -5% is actually not very fast. Not very fast at all. So,
But since it's close, you don't want it to go really fast.
that's true. That's true. Since it's that close, you don't really want it to go really fast. Honestly, I think our target distance is just so short. Being 10 inches away, let's bump that up to like being 2 feet away. Because that way we can have a little more range and numbers there. So now, like, so for instance, like if we're 1 foot away, it's going to back up at -24%, which isn't too bad. Or even better, let me bump this up to 3. Once again, this is just fooling around with numbers till you get one you like. But our right motor spin, it's also going to be forward. And it's going to be the same. We're not going to, it's also going to be, because since we're going forward and back and we're not turning, we want those to be going at the same speeds. And that's it. That's a code. We didn't actually write a function for it. But
Well,
there was
the distance sensor only picks up like 7 feet away, 7.5 feet away.
Yeah.
So it can't get too big.
Yeah, we can't. Well, yeah, we don't want our target too big, but I think a 2 foot away is decent. I can try to put this on a robot. Let me grab a robot. I gotta mount the sensor though.
So what sensor are we putting on this to test it out?
The code we wrote
Distance sensor.
in distance sensor. That's basically the laser rangefinder. If you don't have a laser rangefinder, like if you just have the ultrasonic one, then you are going to have to make some changes to the code. But that's this sensor right here. Well, actually, that's not a laser rangefinder. That is an optical sensor. This is a laser rangefinder. So,
Is that it?
hold on. Let me see your screen. That is a vision sensor. So that would not be. Yep. It's this sensor right here.
Okay.
Yep. And I'm going to mount it. I'm going to mount it to the back of this robot.
I've seen people use some things for air.
I have one.
I think I actually have a use for air. to block off our hopper so that we can use the intake without having to feed out from the hopper.
That's all really good.
It's literally just one piston.
You can have your foot brake, your parking brake.
You want the parking brake, Logan? Just do it nice. Have you checked the toolboxes?
So let me mount this sensor on.
I did not look in the.
Is it in the hospital?
What are you guys looking for? If is it not in the Husky? Oh no. Oh, I didn't. I did tell you that I got a couple of T handles, right? But I left them at the house. I didn't bring them today. I kind of forgot.
Yeah, the T-handle would have been kind of nice for this application.
Yeah, I bet it would have been. Okay, now I gotta find a wire that reaches. I'm gonna need a different wire for this.
Oh, Mr. Where did my wrench go? Do you know?
It works, but I didn't take into account that I have gear ratios, so it's very slow for me.
Show Logan the notebook. He hasn't seen it.
Oh yeah,
Show it to him.
but
I want to say.
you can adjust for that by upping the KP value. Because the higher that KP value is, the faster it's going to go. Of course,
I could just multiply that by my gear ratio, I guess.
yeah, which would be 7, right? Well, no, it wouldn't be 7. It'd be 7/3, right?
Right.
Okay, so I don't have one like that, but I do have a rangefinder
Okay. Now,
where you'd have to adjust your code for that.
yeah. Okay.
See how many steps we have to do?
So
Only 101.
Oh, that's not bad.
the only thing that will change is like line 94. In fact, am I still sharing my screen or no? I'm not.
No.
Oh, okay, let me share my screen again. The only thing that's going to change is how you calculate the error.
Okay.
And I'm going to add a rangefinder in. Or let's say I'm having a ports A and B. Let me. Let me comment out this one. And the only real difference is like instead of saying distance 3, it's going to be like rangefinder A, I think. And I think instead of saying object distance, I think it's just distance. Yeah. Yeah. So instead of saying object distance, we would just say distance. So in other words, it would be like what's it called? A rangefinder. A dot distance in inches.
Okay.
So that's the only difference that you would have in the code. So instead of saying distance 3 object distance, you just say rangefinder A dot distance.
Oh,
yeah.
But that would do the same thing.
He has the notebook. Yeah.
So
Yeah, because you don't do it.
I'm gonna use the original one though, and I'm gonna try downloading that. Let me grab a controller.
The truth is, skirt.com couldn't have done it without me. When we win state excellence, the truth is.
When do you guys want to meet next time?
Yeah, what's the next time we want to meet? I'm off. Well, it really doesn't matter. So,
Because I still have this class for 2 more days, like Monday and Tuesday. But after that, I'll be free like for a couple of weeks until I have to go to Baton Rouge.
so do we want to meet like next Wednesday?
Huh?
So next Wednesday is a little under a week in advance.
I don't care. I work everything else. I work the whole thing. I'm here today.
Well-
Without weekend.
Okay, so let me download this.
This.
I'm sorry for you. You're sorry. It'll
So-
be all right. We're gonna just like we don't get the field finish today. I'm probably about to call my grandfather. That you guys are approved for staying a little bit later, right? Because I want to get this field finished today. So it won't waste any more time. Okay, I'm basically right home here. I'm gonna call him. Yeah, you can. That's true. I'm gonna call him. Are you guys cool with staying a little like maybe an hour later to get the field finished? Yes.
Okay, so I'm going to connect.
I guess I'm working.
Yeah, you need to go to work. You can leave. Like, you're not doing anything. Yeah.
I legit don't do nothing in the office. I finish all my tasks.
He do nothing at work, and then you come here to do nothing.
Yeah.
Okay.
I didn't do that.
Okay, let's see if this code works. Well, I just downloaded it. We'll download it. All right, let's see. I think it works. I think.
Logan, quit.
Whoa! It just took up.
Mr. Madrid, I don't think it works.
What? Oh, battery died. Battery died. It was working.
Is it off? It's just how we did it.
He was driving my way on purpose.
Yep.
I have my KP kind of set kind of high, but so, but let it run off there. It's like a wild animal.
Hence the reason for the dog catcher.
Here, I'll I'll see if I can show you what I got here. There's the robot right there. Let's get in. So as I come up to it, it gets all skittish and backs away from me. But then if I start
can
backing
see
up,
your
it's all
chair.
aggressive.
All I can see is your chair.
Oh, sorry. How about now?
That's good.
Oh, it got stuck. Oh. Now it's seeing the floor, so it's. Oh, okay. All right, get. It's kind of twitchy, but. It's just skittish.
This is a code that you should probably let the kids try without a remote. Just watch the fun.
Yeah, just let it go. And I would probably crank down that KP value a little bit. Well, unless I just like it to see it being all aggressive like that.
So what if you wanted it to turn?
Okay.
That's where you said you need the vision sensor.
Yes.
So I guess that leads into Unit 11.
Yeah. Which I guess, oddly enough, we probably should go over Unit 11 today, I guess. It actually doesn't have, well, it says vision sensor content on Monday, which is basically Unit 11. We could go over that today and then spend like Monday instead, like doing a lot of review for the final. Does that sound like a good plan?
Yes.
Yes.
Okay.
Yes, I would love to review on Monday.
Okay. Okay, so in that case, how about we take a moment then to look at what's in Unit 1. So I'll share my screen again. Sharing my screen.
Can we kill the game design council? Like all of them? If only Greg Cox wasn't a pedophile, dude.
Guys. Okay, so we're going to look at Unit 11, which is about the vision sensor.
He's calling you back. Hello? Everyone. No, we have things to put inside of it.
Okay, so we're going to pull up the slides on the vision sensor, which I'm trying to load up right now. They are slowly popping up.
All right. Yep.
Okay. So let's see what our objectives are. Did we not put any objectives? Maybe we should add some objectives to this slide. I don't know why there's nothing here, but we'll just put in like learn about a vision sensor. So we'll update that more, I guess. Okay, so anyways, so this is what the older vision sensor looks like, but there's also the newer AI vision sensor, and they will do the same things. It's just the AI vision sensor works a lot better. It has a higher dynamic range, so that means it picks up a wider range of colors. Because the old vision sensor, the colors on it are kind of washed out a bit, which is a problem if the whole point of the sensor is to do color detecting. You don't really want it all washed out. This is some information about the vision sensor. It can track up to 7 different colors at once. And it can be used to analyze objects for advanced tracking or path planning. It also has a built-in Wi-Fi radio, which is kind of interesting. Like if you can set it to the Wi-Fi mode by plugging it up through the brain and turning on the Wi-Fi, and then it will actually be like a kind of like a hotspot that you can connect to. And then when you connect at a hotspot, if you go to a certain IP address, I think it's like 192.168.1.1. If you go to that IP address, once you're connected to the hotspot, it will go to the camera feed. So you can actually kind of pull it up on your phone. As you can see, it is relatively low resolution. It's only like 640 by 600. That's not a very high resolution at all. And it runs at 50 frames per second. So it's low resolution, but since it's trying to track objects, the higher the resolution is, the more computational power it takes to track objects. So the low resolution kind of works in its favor of it. So when you set up the vision sensor, let's I'm going to go to VEX Code, and let's just open up the example for the vision sensor. So we'll go to sensing, and we'll look at the code for the old vision sensor and also the new vision sensor. So because I think it has it for both. Let me see here. Where is it? Distance engine. So here's the AI vision. Okay, detecting objects vision. Yep, we'll pick this one right here.
Oh yeah. Yeah.
Okay, so when you use the vision sensor, so this is some interesting code. This is actually using events in this code, which is something that we wouldn't really get to in a this is something that we normally wouldn't get to in the intro class. But it's kind of a different way of doing things. Basically, what it's doing is it's setting these callback functions. And then you see we have this loop here, and it's constantly checking. It's running this check blue, which is an event. And that check blue, and then we have this callback for blue. So basically, what's going on is it's constantly checking if these 3 functions will trigger or not, and it's doing this in a loop over and over again. It's checking to see if these functions will trigger. So, which is an interesting way to do it. There's other ways we could write this too. In fact, we'll look in the slides that has a different way of doing this. But you'll notice here, so we only have the one device set up. When you set up a vision sensor, you do have to kind of set the signatures for the colors, and there's a utility to do that. And so if you click on this open utility, the old vision sensor just kind of has this set up where it has some color swatches. You can also if you just have a picture, you can just capture. Well, if you have the camera hooked up to a USB port, you should be able to click capture image, and it'll take a capture of your screenshot, and you can kind of select the colors off of there. But basically, what you would do to set a signature is like you would say pick one of these. Say I want this signature 6, and I could call it something else, and I want it to do that color. Then it'll kind of set the range for that color. And then so like for instance, let's say I want to set a signature 1, and I want it to be this color here. Then I'm going to click on set. And then what it's going to do is it's going to give me all the configuration data for that swatch there. And so this is what I would actually kind of copy.
Is that data wavelength?
Is that data a what? I'm sorry?
Is that data a wavelength? Like it's detecting like different wavelengths of
You still get paid more than me.
like all the numbers?
It's different hue and saturation and what is it? HSL, hue, saturation. I don't remember. And luminosity, is that what the L stands for HSL?
That's the brightness part of it, isn't it?
Yeah. And so it's basically grabbing all those values, and it's using, and it's also kind of setting kind of a range for that. So so we have like a minimum and a maximum. And so if it's picking up the hue within that range, and I couldn't tell you for sure what the U and the V are, but that's basically what it's doing here. It's got a minimum, a maximum, and the average, the mean. But if it's within that range, if those hue values are in that range, then that's going to detect it as that color. That's basically what all that kind of means, and it's setting it to whatever we call that first signature. And so you can set up to 7 different signatures for 7 different like colors, and if the object sees it, it will kind of pick it up.
The brightness at the top where you have the little slide bar, is that like brightness that you should be setting for like your lighting conditions within your environment?
Yes, I want to say yes to that. Yeah.
Okay.
Also, you can also have this slider right here kind of sets a sensitivity to it. So notice that if I crank it up really high, it might actually, well, might not do anything. This would be much better if I wasn't using just single swatches here. Like if we had a real image that we were using, then basically the higher the sensitivity set up, the more things it's going to detect for that object. So matching up the color, it's kind of almost kind of a pain to work with a little bit sometimes. Let me take a vision sensor and let me see if I can actually get it to pick up. So basically, I'm taking a vision sensor and I'm plugging in my USB to it. I don't know if I need to also plug it into the brain or not. I'm going to go ahead and plug it into the brain just in case. Oh, and I need a battery. Grab a battery. Give me 1 second.
what happens, Michael.
That's
Something comes along.
Imagine if this was the goal.
That was fire.
Oh, let me find a battery something. All the batteries? So it's got some charge on it. Okay, so now that I actually have a,
That's there, so.
and I have it, let me turn this on.
Go ahead and get all the gold pieces that you need.
Well,
We need about 15 of them.
Actually, the battery I grabbed was also dead.
You did? And the other one. Okay. And when you go to put this
Tons of
on,
dead batteries.
just put it on like the very edge of this triangle. Do you have any tape around you? 'Cause I don't know. Hand me that tape.
Okay, so I've got this vision sensor plugged into my brain, and I've also got it plugged into the USB port. So now let me try opening the utility.
We're gonna take it.
And let me see if I can click this screen grab. And I want to use the vision sensor.
That's true. Because you can't.
And that's my screen grab right there. Let me. Hey, could one of you guys? Do you guys have a red object? A red game object?
Toby, right on your laptop.
Could you mind tossing me that red game object? That was quite the toss there, Toby. Okay, so let me take another screenshot of that red object. Okay, so now that I have this red object, I can maybe set a signature for that red object. So I've taken just a screenshot using the camera, and maybe I'll call it. I'm going to call it like a red ball. And now what I'll do is I'll click set, and I'm just going to drag around this ball here and set it. And so now it sees this red ball, and then I can kind of adjust the sensitivity until I'm picking up most of the red ball and not picking up other things. So if I'm too sensitive, as you can see, it's just picking up everything. It thinks everything's a red ball. But if I'm not sensitive enough, it might only pick up like one face of this ball. And I really want to make sure it's picking it up in all the lining conditions. And so I think that's what I want. Now I can also, so I have that one set, and then maybe let me take another screenshot. I'm going to have the red ball in the screen, but I'm also going to have this blue ball in the screen. Let me take another one so I have them both in there. So notice that every time I'm doing the screenshot, it is pretty much recognizing that that's the red ball there. But let's set another signature for this blue ball. I'm going to call it blue ball. And I'm going to set that signature and select this blue ball here and set. Now, it's thinking the screen is the blue ball too. And the problem is there's also blue chairs in the way. So it's thinking that part of that chair is a blue ball. But maybe like that. So now let's see. I'm going to, so it does see that as a blue ball, sees it as a blue ball, sees the red ball. Oddly enough. So this is basically what the camera is seeing here. And so we have these signatures set. And notice if we look at the screen, it tells us our center X position and our center Y position. So that's like where the center of this object is. And it also tells us the width of the height of the objects in the screen, like how many pixels wide and high those objects are. And so we can use that information in a lot of ways. Like for instance, if this camera was mounted to a robot, then as that camera turned, the X position of that red ball is going to change. And so we can use that center X value of that red object to kind of say to turn until it's like, so midway in here is about 150, I think. I think it's 160 is the midpoint of the screen. Yeah, because if it's 640, then half of 640 is 320. That doesn't sound right. That right now it looks like about the midpoint, and that's kind of close to 160. So what I could say is if the X value is less than 160, then I could turn in one direction. Or if it's greater than 160, then I could turn it in the other direction. And then if it's at 160, or once again, we might want a dead zone. So like, say if it's between 150 and 170, then we'll stay centered or we'll stop moving.
So this would be like if you were trying to like line it up to be able to like pick this object up eventually.
Yeah, exactly. Okay. Or like if we're doing our robot parade, and we put a red plate on the back of the robot it's trying to follow, then that can help it line up to follow that robot that's in front of it. Yep. So it has some pretty neat uses. And so to set it up using the old vision sensor, what you do is once you have your signatures, and maybe I made my red ball signature a little too sensitive because it even thinks my hand is a red ball. I guess my hand is just a little too red. I guess because it thinks it's the red ball as well. So maybe I should adjust that sensitivity a little bit, which I can still adjust it here. Yeah, I'll crank that down until it no longer thinks my hand is the red ball. And so now that I have this set, now I can, now that I have these parameters, I'm going to copy these parameters. And then in my utility, I'm going to clear out these parameters. And then I'm going to paste the configuration for those new parameters that I got from the utility. So now it has that red ball parameter and that blue ball. And then I'll hit done. And then if we look, if we go into our pragma, we can actually see this is actually where it's putting all those parameters. So that's all kind of hidden there. But so but it's setting up that it's looking for a red ball and looking for a blue ball. And these are like all those basically hue and brightness and saturation parameters right there. That's all in that hidden code. Now, I broke this code. This code's not going to work now because I no longer have this Vision 5 red box in there anymore, blue box, because I set it up looking for a red ball and a blue ball now. So if I try to run this code, it's not going to work. In fact, I'll probably get errors now. Let's see what happens. Actually, I really don't want to save this. Yeah, and it's got errors. Yeah, because it doesn't know what this blue box, red box, and green box are anymore because I wiped out the old parameters that had that to set up these new ones. So let's look at so that's how you set up your signatures. And then once you have the signatures, well, what do you do with them? So we're going to want to do this in a loop. And so here are, once again, some ways we can do an infinite while loop. We can just say while true or while 1, because 1 means true, or while 1 is equal to 1. So because 1 is always going to be equal to 1, so that'll always be true. So those are all kind of different ways we can do an infinite while loop. And what we're going to do in this case, this error here is not actually an error. If I were naming this variable here, I would call it dead zone, because that's what this is. This is kind of a dead zone that it's setting. And so it's basically setting a dead zone that's 15 pixels wide. And we're also setting, we're basically making a variable to keep up the center, and it's saying the center is 150, which I guess it might have been 150. I was thinking it was about 160, but it could be 150. And it's saying 150 is the center of the screen. And that's what this variable is saying. And so basically, and then we have this movement code here. And basically, it looks like this movement code, when we feed it in, and this is actually kind of an old style of doing things. We don't do it this way anymore. So, so let's not worry about that. Okay, this is the code we kind of want to look at. So when you're trying to use a vision sensor, the first thing you need to do is you have to take a snapshot. Just like how when I was using utility and I was like clicking the button to take a snapshot, and then it was like detecting the objects that were in that snapshot. That's also kind of what you need to do with this. But when you take this snapshot, you also have to specify what object you're trying to take the snapshot of. Like how I made like a red block, or did I call it red ball? Yeah, I made a red ball and a blue ball. In this case, it looks like they made a signature called PG. Which I don't see here. But instead of PG here, I would probably say like red ball, because that's like what I called one of my signatures. And so your snapshot is, once you take that snapshot, it's only going to be looking for the object that you're specifying in there. So, so in this case, I'm only looking for the red balls, if I said red ball in there. And then we actually, this code here has a nested kind of loop here. So this first if is like if it actually sees a red ball, like if the largest object exists. So if it actually sees a red ball in its field of view, that object exists. What it's going to do, it's going to do all this code here. And we'll get into that code in a second. But else, if it doesn't see a red ball, then its movement is going to be like 10, -10, which is basically controlling the left and right motors. So it's basically making the left motor spin forward, the right motor spin backwards. So basically, it's going to do a turn. That's what this code kind of means. So if
you're
it's
lining up to the object now, like you're trying to like shift the robot to the object once it's detected it.
Yeah, well, yeah, basically, if it sees an object, then it's going to do the lining. And that's what these other ifs are, which we'll talk about in a second. If it sees an object, it's going to try to line up to that object. If it doesn't see an object, then it's going to spin around, and then that's going to loop. So it's going to spin around until it finds an object. And then it's going to try to line up to that object. And so what it says here, so if that object center is greater than the center FOV, which we set to 150 plus the error. So that once again, that error is really a dead zone. So so if the center of it is 150 and the arrow was what, 15?
Yeah.
Was that what I said? Yeah, 15. Then that means if it's greater than 165, it's going to turn in a direction. And I guess that turn in that direction would get it kind of closer to the center. Else, if it's in the center minus that arrow, so that would be 135, then it's going to turn the other way. Otherwise, I don't know why, but otherwise, that would mean it's between these two numbers. So it's between 165 and 135. It's going to actually back up. And I don't know why you would want it to back up, but I would probably just say motor stop or just set these values to 0 is what I would probably do. But they have it set up where it's going to back up if it sees the object, because both motors are going to be spinning backwards. So here's the situation this code is going to do. It's going to look around. It's just going to be moving if it doesn't see an object. And then when an object gets in its view, if it's greater than that center, it's going to continue to move until it's between these values here. And then it's going to back up for whatever reason. Back away from it is what's happening here. But that's basically what it's doing here. And this is doing it with if statements, but we can also do this. We can also do this with our proportional code. So in that case, our target value would be our center FOV. And then we could just change our speed in proportion of like to how far away it is from the center. Does that make sense? Now, if you want to track multiple colors, that requires taking multiple snapshots. So in this case here, it's running this big loop here. And if it sees red, it looks like it's going to do the code to center up of the red. And this time it's actually moving towards the red. It looks like it's doing a swing turn when it's doing that. If it sees orange, then it's just going to turn. And if it sees green, it's just going to stop moving. So yeah, that's kind of what this code is doing. And it's going through and checking each of those conditions over and over every time it goes through this loop here. But every time you want to check a different color, you have to take another snapshot and for that signature that you're trying to check for. And that's kind of what's going on here. Yep. So if we wanted to say write a code that maybe track this red ball, we could try doing that. So once again, let's just do a whole new test project.
One side of like each side, or
like so this side.
Let's add
The screws on this side are gonna have nutted.
a left motor and a right motor.
The screws on this side are gonna get nuts in, and then on this side, nuts out.
Do we need to write this code while you're writing it?
No matter which side you do, one side has all nuts.
Well, if you did, you would have a code for later, right? So it wouldn't hurt. That way, like when you later have a vision sensor, you can have that code. I'm just going to call this code, I want to call it track red. So it's going to track a red ball. And I'm just going to fill out my header like I always do. And I forgot what today's date is, as if I couldn't just look at the bottom. Yes, it is Friday the 13th. Means bad things are going to happen.
Bad things have already happened.
Okay. So in addition to the red motor and the blue motor, I'm sorry, the left motor, the right motor, we're also going to add a vision sensor. This one is plugged into port 4 right now. So I'm going to pick port 4. And we're going to go ahead and open up that utility too. Because we're going to need a signature. Now, what you guys can do, especially if you don't have the vision sensor to work with, you can just maybe pick the red swatch here and maybe call it red ball or something like that. So the way you do this is once you have that utility open, click one of these signatures, type in what you want to call it. In this case, I'm going to call it red ball. Then click the set. And then I want to maybe pick this to be my red ball. And that's going to give you these parameters here to work with. Well, that doesn't seem right. Yeah, there we go. Yeah, make sure there's actual numbers in the parameters. Now, so that's what you guys should do if you don't have the vision sensor right now. I really wanted to be able to detect this actual red ball. So I'm going to actually use the image capture so that I can see. It was working before. Why isn't it working now?
Logan just got done with his very arduous scrolling on his phone. Now he has to rest.
Let me try it.
Logan, can you whip it and get the
Well, let me try open that utility again.
Remember that, like, 4th grade, they had to go into the classroom and they had to keep like that. And they was, yeah.
That's second grade. Yes, no, second grade.
When you get here,
We stopped you after.
It was literally working a second ago. You guys saw me use it, right? Earlier.
And now all you're gonna do now is you're just gonna split these in and you're gonna.
I'm trying unplugging it all. Try turning everything off. And turning everything back on again. Doing all the things. Maybe I have to.
Yeah, there's a good chance that we're just blind, or we don't have it. Logan, go look for one more base.
Well, I can't get my screenshot to work. It was working the first time, but no, it's not working. I wonder if I still have that configuration copied. Let me see.
How did you get back to
Okay.
the main screen? Because I can't find a back arrow in my configuration.
It opens up.
ability.
It opens up a different tab.
Oh,
Is it that one right there?
Yeah.
Ryan, is it behind you?
Yeah, it opens up a different tab. But anyways, once you have your signature, hit this copy config button. And then what you're going to do is you're going to click on paste config, and it should paste that configuration data in there. Fortunately, I still had that saved from my screenshot. And then you're going to hit done. And so you should now have a signature for a red ball if you did that. And you can kind of look in here. Yeah, so I have a signature for both a red ball and a blue ball. Okay, so now that we have that signature, we're going to make a big while loop. We want something to repeat over and over and over again. And in this loop, the first thing we want to do is take that snapshot. And so, once again, if we go into sensing, we should see like vision, and we see this take snapshot. We're going to drag that in. And then the signature, let me just try red ball. I think we have to do vision for red ball. Yep, like this. And let's build that, and let's make sure that works. Yep. So we're taking a snapshot of that red ball. I'm kind of skipping a few things, aren't I? Because I haven't made any variables yet. So let's make some variables. Create variables.
Yeah, Mr. Brightside. That's what I'm saying, dude. Mr. Brightside is fire.
So I'm going to make a variable. I'm going to call it target. And that's going to be like my target being the center. The center of the screen, which is probably going to be 150. Because that's what it said in the slide. So let's go with a target of 150, and that's going to be where I want my center X to be. Let's go ahead and do an error, and this error is going to be an actual error, and we're going to and it's going to be a float, and we'll have it set to 0 for now. And then we'll also have a KP value. So we'll have a float for a KP. Since the numbers we're working with are going to be like between 100 or less than 100, let's maybe set it. I don't know what a good number for that would be. Let's set it to 2 for now. I think 2 will probably be okay. Yeah, 2 should be fine. Let's set it to 2. If it's turning too fast when it's tracking the object, then we probably want to crank that down. But we'll set it to 2. Okay, and so after we've taken the screenshot, we were going to do an if statement, and we want to say, like, if the object's found, we want to try to center with it. Else, if it's not found, then we may want to just continue spinning in a circle. Or maybe if it's not found, we just want it to stop and not do anything until it sees an object. I guess that kind of depends on what we want. I guess maybe we should set it to spin around so that it will just continue to spin around and search for an object. So let's do that first. So what we're going to do is we're going to say if, and we're going to, let's write our condition in just a second. Well, actually, it's really easy. We don't even, what we want to do is go over here and say, you see where it says vision largest object. We'll drag that in. But then we'll say largest object exists. And I think we have to do an open and close parentheses after that. So if the largest object exists, then we're going to do like all our centering stuff. And then outside of that, but still within our loop, we're going to say else. This is what we're going to do if we don't see an object. In which case, maybe we should continue to turn to find an object. So what we could do is say, we could say left motor dot spin forward maybe 50%. And we could say right motor spin reverse 50%. Okay. So what we have so far here, and let's build it to see if it works. We got an error. Maybe we're not supposed to have these. Maybe it's just supposed to be like this. Oh, still an error. Let me.
You left off your parentheses. You were supposed to take off the open and close, but you also took off the end parentheses.
Yeah. Okay. Okay. Yeah. So if the largest object exists, then we're going to fill it in and do our auto straightening stuff here. Oh, not auto straightening, but our lining up code here. Else, if it doesn't exist, we're just going to be spinning. And that way, maybe it'll spin until it sees an object. So that's what we have here. Now, it's just an issue of doing our actual like lining up at the object now. And so we're going to calculate an error first. So our error is really just going to be, we're going to do this vision for largest object. Because the largest object should be like our closest object. And we're going to grab the center X. Because that's the X value of its center. Of the center of the object it's seeing. And I guess we probably don't need anything after that. And then we're going to subtract our target number of 150. Because we're pretty sure that the center is 150. And so if we've seen an object and it's right in the center, it's going to do 150 minus 150, and that'll be 0, and we'll have 0 error. And we can build that and make sure it all works. Okay, so far so good. And now we just need to make our motor spin.
My question is,
So
how do they build a show around
we'll do a left motor dot spin. I guess we'll go forward. Now the speed we want to go forward is going to be basically our error times our KP, or our KP times our error. And
You don't like it?
I guess we'll do in the percent.
Quit looking at my table.
And a right motor. Ooh, I just heard my. So it's going to do the same thing, but in reverse of the KP times the error. Percent. It would be kind of nice if we had a nice visual on the brain that we could easily see to know if it's seeing the thing or not. How about instead of like what we normally been doing is we've been printing stuff to the brain. What if we made the background of the brain be different colors? So if it sees a red object, it's lit up red. Otherwise, it's lit up blue. How about we do that? Sound like a neat thing to do?
Yes.
Because we haven't really done anything like that. It's really easy to do, though. We just say, I'm pretty sure it's. I think it's brain screen set fill color, and then we may have to draw a rectangle around the brain, maybe. No, that's the fill inside of a rectangle. Yeah, so we might have to draw a rectangle for that. But yeah, so let's try that. So we're gonna grab this brain screen set fill color, and it's gonna be red if we see, and then we'll just draw a big rectangle. And what's the biggest rectangle can draw? What are my corners? So we would do. It goes from 0, to 479, 239 is what it's saying here. So that's probably the dimensions of the rectangle we want. So we're going to draw a rectangle, and we're going to go from 0, to 479, 239. And in case you're wondering where I'm getting these numbers from, it's because I'm looking right over here, and I'm seeing it starts at 0 coordinate up here, and it ends at 479, 239. So that should be. Well, okay. Yeah, that'll do it. That'll do it. Because it's the top left corner, top, and yeah, those are the coordinates where we're going to start at. And then that's going to be the width and the height of the rectangle. Yep.
That's a good one.
And then let's actually do the same thing. We'll copy this, and then if it's not seeing it, I'll just change the color to like maybe green. And I think that's it for the code. I think this will do it. The only thing that might be an issue is I might have my forwards in reverse the wrong way, in which case it will actively try to avoid the red object. So like if it has a red object in its view, it's going to like turn away from it if we got these wrong. But if they're right, then it should turn towards the object until it's centered. If these are wrong, then if you try to put it in front of it, it's going to like try to turn away from it, like get away from it, which also might be a neat behavior for the robot. So I'm going to
Do we
try.
even need to have the forward or reverse?
No, that is an optional thing. We can leave that. Well,
And just do the negative for
yes,
one of them?
you could take off that and do a negative on one of them. Or maybe you can't. Because I just got an error when I tried to do that. So I think I might need the direction. But I could do a forward and a negative direction. I could make them both forward, but I got an error when I tried to leave the direction off. But I'm not getting an error now. I'm going to download this, and I'm going to just download it to this brain. Because at the very least, I'm downloading to a brain, but it's not hooked up to a robot or anything. But I have the vision sensor plugged in. And at the very least, I should be able to see that the screen light up either red or green, depending on if it sees the.
You can just take breaks. I'd rather take a break and get nothing done. You just offered, bro.
Okay. Oh. Okay, so I'm gonna unshare my screen for just a second, and I'm gonna move. Can you see my brain here?
Yes. Well, not anymore.
Okay. Can you see it now? Or do I need
Keep
to
moving it towards you.
Is that better?
That's fine.
Okay. And see it's red right now? Okay. So I moved the object away and it's green. Now I'm moving the object towards it, it's red. So it is actually picking up that object. So if I were to plug in the motors, I should, if I had this actually hooked up to the robot, the motors would be doing stuff too. But that's working pretty well. At least that part, at least I know that part of it's working. Yep. So, and if you want to see what I'm doing, I'm just like waving it in front of it or moving it away. And it's picking it up. Actually, yeah, now you can kind of see. So it sees it. Well, let me move it out of the way. It doesn't see it. I wonder if it thinks the text on my shirt is also the object as well. So anything red, that's that same value of red, it's going to think it's that object. So
How much do you think of what they tell us about North Korea is real?
but that's how you can use the vision sensor. That's pretty neat, right?
It's possible. I
Um,
really don't believe that.
Yeah, I need to get one.
Yeah. The AI vision sensor, by the way, it's kind of the same except for the software for it's a little better. Like the utility it has is better. In fact, let me hook up an AI vision. Of course, I need a USB-C to connect it. Let me see if I have a USB-C cord in here. I should have one somewhere. So here's an AI vision sensor, and I'm going to hook it up. So to calibrate it, you have to plug it into the brain, just like how we did with the regular vision sensor. And you also have to plug it in USB-C to the laptop. I'm just going to add the device. I'm going to share my screen again, just to show you what the utility for the AI vision sensor looks like. So I'm going to add a device for this AI vision sensor. I'll maybe put in port 5 this time. I'll need to make sure I plug in a port 5. So I'm going to hit configure. And I'm going to connect. And you can see this utility is a little fancier. Yeah. And so it actually does, instead of just doing screenshots, it does kind of like real-time video here. It even has some nice fancy instructions on how to use it. And so let's say I was trying to pick up this red object. So what I'll do is I'll get over it and I'll freeze the video. And then I'll give a name for this. I guess I could also call it maybe red ball. I'm going to call this one red block just to be different. I want to add color. Well, not add color. I need to, well, I guess I need to freeze my screen again. Oh, and there's even new firmware up. That makes sense. Actually, let me do this update real quick. Let me update the firmware on this brain. I mean, on the vision sensor. One cool thing about these firmware updates is it actually has some AI training models for the latest game objects. So I think that's what this new update will have. And did it finish? It still says new update available, but I thought I just updated it. Let me close it for a second and come back in and see if it recognizes. Well, maybe not. Okay. At any rate, let's call it red ball. Let's freeze this video. I want to set the color. Oh, I have to drag first, I guess. So, and I'm going to set color. Let me. Why is it not frozen? And I guess it might be set. I don't know. It's not showing it's recognizing it yet. Did I follow those instructions wrong? That's what it's supposed to do. Let's try that again. I'm dragging a box around it. I'm going to click set color. Then it's supposed to put a box around it and say that it's finding it. Doesn't seem to be doing that part. Let's see if Let's see if it picks it up as a competition element. Oh, okay. Oh, my brain turned off. I haven't actually played with this vision sensor a whole lot, so not the new one. Let's update the model. Please restart your vision sensor and try again. Update the model. Auto update field, please.
Alright. So here's a full goal, guys. And then I'm just gonna hit it.
Um, sorry about that, guys. It's probably going to take me a little bit to work with this, but I think you guys get the general idea, right? The general idea being that it's not working. Hey, at least we got the older one to work. Okay, so, yeah, we got the older one to work, and it was working just fine. And the newer one, I'm just having trouble updating it. But if with the right firmware, it is supposed to recognize the latest game objects, which is kind of nice. Assuming we can get the update to go. And also, you probably noticed with the newer one, it did have an option for April tags too. I don't have any April tags printed out right now. Actually, there is something I can do about that though. Let me try this. Let's just look up an April tag. And if I can just get a screenshot of an April tag, I can just point the camera at that. Yeah, so let's see if I can do that. Okay. Am I still sharing a screen?
No.
No. Okay. So let me share a screen. And watch this not even work. Okay, I think I'm now sharing a screen. So I split my screen. I got some April tags up here. Let's try hitting configure again. And let's grab my camera here. And let's turn on April tags. So now it should be looking for an April tag. And there's an April tag. Will it recognize it? Do I need to do something special for it to recognize it as an April tag? Well, okay, it saw something as an April tag. For whatever reason, I want to. It's picking up that one right there, and both of those as April tags. One interesting thing about the April tag is you see we actually have a lot of information there. Not only do we have like the width and everything, but it also even gives us like a an angle. So it's got our X, Y, our width and height, and then the angle. So like for instance, if I turn sideways, do you see how that angle is changing on those April tags? So now it's at like 38 degrees or 33 degrees. And if I turn it like this, now it's at like 0 degrees. So it also keeps track of the orientation of that April tag, which is pretty neat. Kind of surprised. So it likes these April tags.
And then like from here, all you gotta do really is put some
So I imagine in the future, or our locations on the field tags, just like how it is in oh. Just like how they do with FRC, and they use April tags on those fields. Yeah. Okay, so as I said, on Monday we're going to do a lot of review over the final, and like I found the copy of the final I gave my students last year. So I'll look through those questions and make sure that we understand everything that will be on the final. So you guys should be pretty good for that. I wouldn't worry too much about it. So
Would it
as far as
also
the
be in that shared folder of robotics that you shared with us already?
well, it will be. The final will be in that shared folder. It's just Vanessa removes it during the summer training, so that you can't just grab all the answers. But she'll put it back in there after the summer training's done.
Gotcha.
Yep. So, and so like when I'm reviewing, I won't just tell you what all the answers are, but we'll go. I'll look through the questions to make sure, and then explain the topics and what you need to know to answer the questions, just to make sure that you have all the information. So, So without outright giving you the answers, I will at the very least make sure you have the information you need to know to answer the questions. Yep.
So for today, are we just in Google Classroom, are we just posting our Roomba code and video? And then whatever we decided to use for our final project and that video, and then that's pretty much
Yes.
for today.
Yeah, that's what we'll post today. And like I said, when I get back home, I'll be able to get on my personal account and actually put that assignment up. But that's what you're going to put in there. Yeah, just
Got
your
it.
video and your code. Yep. And if your final is your Roomba code, then that will be it. Yep.
Cool beans.
So, okay, so we'll just turn over to asynchronous now for till 1. But if anyone's stuck on anything, I'll be on at least till 1. Might stay a little longer if. So here's how far they've gone with the field so far. So they're working hard over there.
Working hard or hard work? I know Logan too.
Yep. All right. So I'll just be on mute, but if you need anything, yell out and I'll come running over here and answer up. Yep. And I hope everyone has a good weekend, and I'll see you all Monday.
Yeah, I'm gonna go ahead and sign off because I have to build a 12-inch conveyor belt system that is a double conveyor belt. So I have a lot of work to do.
Yeah, so that's for the engineering, right?
Yeah.
That's the. Is that the one that made it out of like toilet paper tubes and stuff, or?
It doesn't specify what you have to make it out of. That's what I was gonna do. So
Yeah.
we'll see how it works.
We're seeing some kids with that, doing it like that. Yeah.
Yeah. So, all right. Well, y'all have a good weekend.
You too.
I'm logging off too. Have a good weekend, y'all.
All right. And we'll review over that test Monday. Well, that's going to. Okay. All right. Are you guys logging off too?
Yes.
Yes.
I think I'm
Okay.
done for today.
Okay. Well, yeah, that's fine.
I mean, not,
If
you know, I'm still working on some stuff, but yeah.
Okay. All right. Well, have a good weekend.
All right, you too.
You too.
Yep. Ooh. Yep. Are you leaving too, Josh?
I can.
Oh, you don't have to. I'm not trying to run you off, but in fact, if you, yep, like
So
if you
my
need some,
thoughts were for my final part. I've hooked up a optical sensor beside my distance sensor, and I'm going to try to run the robot towards like a red binder maybe, and then when it sees the red binder, the optical sensor picks up red. It's going to tell it to turn to the right, and then travel until it sees something else, and then whenever it sees that, it'll be like maybe blue, and tell it to travel to the left, and then I don't know. I was thinking maybe some other color, make it stop and or something like that, and that would be the end of it.
yeah, you could,
Maybe maze-ish.
yeah, and it could be if you wanted to, instead of making it turn, you could do just something like making the screen light up red if it's seeing red, or and lighting up blue if it's seeing blue, or something like that. So it gets to it, and then it says what color it is on the screen.
Okay, and then well, I was still thinking like it has to go or do
Something. Well, yeah.
Yeah, I mean, otherwise that would be. I mean, I'm okay with basic, but I was trying to be a little bit more complicated.
Yeah. Okay. Yeah. Yeah. So you can use those colors as kind of like, well, if it's seeing red, then the next part it's going to turn 90 degrees.
Right. That's what I was thinking.
Yeah. Okay. Yeah, that would be neat. I think that'll be a good project.
Okay. Well, thank you, sir. I'll piddle with it.
All right.
And hopefully I'll have something decent by Monday.
Okay. Well,
Okay.
have a good weekend.
Yes, sir. You too. Have fun the rest of your day.
Yep. All right, log it off.